It's not required. I'm not coming.
Okay.
Sena sir will be joining now.
Okay.
So everyone to notice that now we are on live YouTube. So we'll be starting very shortly, sir. So everybody will be now getting that whole video through YouTube.
Yeah, good afternoon, all of you. Good afternoon, all of you.
Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir. Good afternoon. We are live now in YouTube.
Good afternoon,
Good
sir.
afternoon.
So we can start the proceedings. Very good afternoon to the respected chief guest of the function, Dr. M.N. Rajivan, sir, Secretary MOS. Respected distinguished scientist, Dr. Sailesh Naik, former Secretary and Director, NIAS, and all our respected speakers who will be delivering talk in our session. Respected DG, Dr. M. Mahapatra, sir, and also President of IMS. Respected Dr. Ravichandran, sir, Director, NCOA, and also the President of Ocean Society of India. Respected all viewers from IMS fraternity and also the Ocean Society fraternity, and all my dear friends. It is my proud privilege to extend heartiest welcome to you all on this inaugural function of World Meteorological Day, that is on 23rd March we are celebrating. This is an auspicious occasion for all the meteorological fraternity, and since its establishment in 1950, we are celebrating, so it is actually 72 years we are celebrating this World Meteorological Day. And this theme of this year is very interesting: the ocean, our climate and weather. The ocean, this is about 70% of the earth is covered by ocean, and it not only responsible for the weather forecasting, it also maintains the global climate balance. It also generates a lot of oxygen. It can also store the 50 times more than what atmospheric carbon dioxide is there. So it is very crucial part, and also millions of people depends on its food, economy, etc. also influenced by this ocean. And starting from our weather forecasting services, actually, if we say the long history of 1904, we started the NWP, numerical weather prediction. That was the only exploration. We are exploring only the atmospheric part, and after more than 115 years, etc., we have reached to a stage. And in between, in 1956, the Norman Phillips, that because of his efforts, we could get the global atmospheric model. So that was initially the atmospheric model, global atmosphere in 1956. Then slowly the ocean exploration also started, means how to integrate the ocean into atmosphere. And in 1960, the Kapul model in the GFTL, that is the USA, Geophysical Fluid Dynamics Laboratory, that was introduced in 1960. And after that, more refined Kapul model have come up, and now we are having a Kapul model, ocean atmospheric Kapul model, with all type of means covering all type of time scale, means starting from your short range like intensification of tropical cyclone. There also we need Kapul model, hurricane WRF, to your medium range, extended range, and also seasonal program. And another milestone of, if you consider this theme of this the ocean atmosphere and thing, the Ministry of Earth Science. The Ministry of Earth Science, earlier it was also a separately working, if we consider the present constituent of IMD, IITM, IIT, this INCOAS, etc. In they were some part were under the DST and some part were under the DOD. In 2006, 29 January 2006, there is merging of this all the atmospheric part of the DST and along with the DOD and the Ministry of Earth Science form in that. So that means there is also a need for, we also realize the necessity to how atmosphere and ocean means departments should also converge together for the further improvement of weather forecasting services covering both the disciplines. And another milestone that we will be going for today is the two society, Indian Meteorological Society. It is a long history. In fact, 1957 it was established and it was registered under Society Register Act in 1972. And various functions, we have various functions of population of science and also encourage research and development. All these things IMS is doing very well. And the Ocean Society also, it was also established in 2006 along with the year when the MOES also was established. So now it is a unique opportunity that we both the society are going for an MOU signing MOU just to encourage activity, atmospheric and oceanic activity together. And there are many benefits that we will be getting after the signing of MOU. And one thing is that one part is that any live member of one society can be a live member of other society by paying the 50% of the live membership fees. So that is also one part to encourage how the scientists from one society will work with the scientists of other society. And as it is already known that is the couple, just like couple motion model, couple department MOS, now it will be a couple society, means both the society will work together. So this is a unique opportunity covering the theme of this WMO day, and we will be having a very interesting session also. And our chief guest, Dr. Rajivan sir, he will be chairing the session, and he doesn't need any introduction to the Met fraternity, but just to say one or two few lines about him. That earlier he was before joining IMD, he joined as a he joined TAFR in 1983, and also IMD he joined in 1985, and basically known as Monsoon Man of India. His prominent contribution includes the study of dynamics and energetics of Indian summer monsoon and prediction on seasonal time scale. He has contributed immensely the understanding land surface process of monsoon variability, regional climate model, study of the cloud radiative forcing over monsoon region, analysis of active break spell in Indian summer monsoon, and understanding the physical processes associated with extreme weather events. The statistical model that was developed for long range forecasting was his contribution is on that. And also the gridded rainfall data, now it is widely used by the world community. That was also his contribution when he was in IMD Pune. And then before he joined as a secretary MOS, he had also served in NARL and as a brief period as a IITM director, and before he joined in as a secretary MOES. Okay, then coming to the significant awards and etc., his contribution: Start Young Scientist Award in 2001, 20th Biennial Award MOSAM 2001, Young Scientist Award of Atmospheric Science by MOES 2007, Fellow of ISC, and INSA, and also the Indian Meteorological Society, and also the member of the International Academy of Astronauts. So we are very fortunate, sir, that you will be chairing the session for the inaugural session of this event on a very auspicious day of WMO Day. And without taking much time on this thing, and thanks to all the speakers who will be delivering the talk, and again best wishes to all the viewers on this auspicious day of WMO World Meteorological Day, and I welcome you once again for this important session. Thank you very much. Now we'll start the proceeding for the other distinct speakers. So now I'll request the opening remarks by Dr. M. Ravichandran, the President of Ocean Society of India and also the Director of NCOR. Please, Ravichandran, sir.
Respected Dr. M. Rajivan, Secretary to the Government of India, Ministry of Earth Sciences, Dr. Sailesh Naik, Director, National Institute of Advanced Studies and former Secretary, Ministry of Health Sciences, Professor U.C. Mohanty, IIT Bhubaneswar, Dr. Senai, former Director of INCAIS, Dr. Krishnan, Head of the Center of Climate Change, IITM, Dr. Mohapatra, President IMS and DG IMD, Dr. Patnaik, Secretary, Indian Meteorological Society, and Dr. Jana, Secretary, Oceans Society of India. Members of Ocean Society of India, Indian Meteorological Society, researchers, invitees, students, and all participants of this E-symposium, very good afternoon and welcome to this E-symposium. As Dr. Patnaik already mentioned, this year WMO theme is the ocean, our climate and weather. And hence this E-symposium is organized by both IMS and OSI. Accordingly, we have selected 2 eminent speakers from atmospheric side and 2 from the ocean side. So we will be listening their talk today. Ocean Society of India was formed in 2006 at Kochi with a humble beginning of few members for sharing the knowledge and experience of individual scientific institutions and industrial organizations in ocean science, technology, engineering, and allied fields. It has presently 3 local chapters, Kochi, Chennai, and Pune, and now we are become more than 500 members. OSI is always produce a news bulletin, quarterly news bulletin. It is called Ocean Digest, and also OSI conducts biennial conference. It is called OSI conference. It is OCCON. Every 2 years it has been conducted, and this year this will be held in NCPOR in August. OSI also started many awards, including Dr. Srinivasan Endowment Award to honor eminent scientists, engineers who made outstanding contributions in the field of science and technology for the national development and their applications. Recently, we started PG Dissertation Award to young students, MSc students, all the 7 branch, actually different discipline, including science and technology, atmosphere, and different branches of ocean science. And from the year 2021, OSI is also instituting a fellow and also honorary fellow scheme. So this advertisement will come soon in the coming months. This E-symposium is a good initiative by both OSI and IMS, and I am sure similar type of webinar series or E-symposium will be organized in future. Maybe the next one will be in the Ocean Day, World Ocean Day on June 8th. I personally feel that both societies, IMS and OSI, should work together and initiate more awareness and outreach program in the coming years. On behalf of OSI, I once again thank Secretary, Ministry of Earth Sciences, and all 4 eminent speakers for readily agreeing to deliver the talk of today's event. Thank you, one and all. Thank you very much.
Thank you, Ravi Chandra sir, for your telling about the Ocean Society of India, and people are not very much familiar, so that is a good opportunity that they listen to this thing. Now, may I now request our respected DGM sir, Dr. M. Mahapatra, who is also the President of Indian Meteorological Society. Over to you, sir.
Respected Secretary, Minister of Arts Sciences, Dr. M. Rajivan, Dr. Sailesh Naik, ex-secretary and presently Director NIAS, Professor U.C. Mohanty, IIT Bhubaneswar, Dr. Krishnan, IITM Pune, Dr. Sinay Saab, ex-director INCAIS, Dr. Ravichandran, Dr. Patnaik, Dr. Jena, and my dear friends and colleagues from Indian Meteorological Society, Ocean Society of India, from various institutes, Minister of Arts Sciences, sister organizations, press and electronic media, ladies and gentlemen, viewing this program. At the outset, I congratulate the entire community on the occasion of World Meteorological Day, and I wish everyone a happy World Meteorological Day. As Dr. Patnaik was telling, World Meteorological Organization came into existence in 1950 with the signing of convention among the countries, and then onwards, every year it is celebrated as World Meteorological Day with a special theme. And this year, the theme has been Ocean, Our Climate and Weather. As the theme suggests, the weather and climate at any part of the globe cannot be independent of the ocean. And as the fraternity and Minister of Earth Sciences, all of us know that weather has no boundary, and it is just the byproduct of the interactions among the processes from the Earth's surface, ocean surface, and the atmosphere. If you consider the recently declared UN Decade of Ocean Science and Sustainable Development for 2021 to 2030, it becomes very timely and important to have this theme in this year of 2021. The ultimate objective, if you look at any particular country or world community, is to ensure that the loss of lives and properties are minimized worldwide because of the various types of hazards and disasters arising out of this Earth's surface, ocean surface, and the atmospheric interactions. The various types of hazards which affect because of this interaction are mainly the monsoon, tropical cyclones, thunderstorms, squalls, waves, swells, and strong winds. And all these parameters cannot be monitored or predicted simply considering the oceanic parameters or simply the atmospheric parameters. So this was well understood from the very beginning. And of course, recently in the policy makers, this point was well taken off. And in 2006, we came up with the policy guidelines and a structural organization with the establishment Minister of Earth Sciences to address this collaborative objective. As a result, you will find that under the Minister of Earth Sciences, we have got many organizations who are working together. And this is because of the able leadership of Dr. Rajivan Saab, that in recent time you will find that everyone talk to each other. As a result, the knowledge, experience, and expertise of each individual and each organization is tuned towards each other. And final output is that Minister of Earth Sciences has achieved a lot with respect to monitoring of all the components of Earth system sciences, its prediction, modeling, forecasting, and early warning services. So as a result, we are working forward to ensure a safe ocean, a predicted ocean, and also a transparent ocean. Especially when you consider the blue economy, yes, certainly worldwide, ocean is very important to have our economy in place. Considering this, our ministry has also taken off a deep ocean exercise, and we are also gearing up each other to work in this direction. Especially if we look at the hazards, marine hazards, we have come a long way to minimize the loss of lives, but still loss of property is quite high, and still there are challenges. And if we look at all these challenges, what we find actually, there is need for augmenting the observational setup, the modeling, impact-based forecasting, research and development in this line, and also awareness and capacity building among the users, mainly the vulnerable population like fishermen, marine community with the smaller ships, trawlers, or the high sea shipping. There are also avenues to improve further to give more specific and granular information to the shipping community with higher leading period and also with higher accuracy. Now, if we look at in view of the climate change aspects, yes, certainly there has been a threat, though the sea is helping us by the way of absorbing more energy from the sun, and hence sparing the atmosphere to have only 2.3%, where ocean is absorbing about 90%. But still, the problem arises because ocean cannot continue to be hotter and hotter. If you go on assuming that ocean is there to help us, but that heating of the ocean may lead to the increased frequency and intensity of various types of marine hazards. Hence, it may also affect the marine life. So as a scientist from marine community or Earth system science community, we have to work together and address all these issues. I'm really happy that we have got very good experts today, the 4 well-known experts who will speak on the various aspects of this coupled process of ocean and atmosphere and its impact, and hence the remedial measures to be taken up by the scientists and general public and the disaster managers. I am really thrilled to listen to all our experts, and I'm grateful to all of them to making this possible to participate in this. I am really grateful to Dr. Rajivan, Secretary Minister of Sciences, for sparing his time for this particular event and giving his ideas and opportunities to be listened by all of us. So thank you very much. I hope both Ocean Society of India and Indian Meteorological Society will work together with the establishment of a memorandum of understanding between the two organizations. We have come up with the structural measures with the establishment of the Earth System Sciences Ministry. We have come up with the modeling process coupled to each other. We have come up with the combined observational approach, but still there is need to go for extending our services and explaining our services to the general public to make it realized. So therefore, both these societies can work together for propagating the information on ocean and atmosphere and helping the people to combat with various types of agonies arising out of these disasters, especially in view of the climate change. So thank you very much. We will perhaps we'll go for the next item. So thank you very much.
Thank you very much, sir, for highlighting how we are working together, the Met community, the atmospheric community, and also ocean community. And after this event, we will further enhance our collaboration. And our basic focus is to reduce the disaster risk for the extreme weather. That also will work together. Now going for the next item, this is the signing of MOU. Since we are virtually doing this event, so today morning we just respective places our society president from IMR, Dr. Mahapatra sir, and the Ocean Society president, Dr. Ravijan sir, they signed in respective places, and we have got a small video that we will be sharing just to see, and I'll request now Dr. Anandas to share this thing. And the basic, yes, philosophy, if I read out one or two sentences about this, you can start showing the thing. Collaboration and information exchange. So each website will have some information exchange between our IMS website and this website. And also the meeting cooperation. Every year we are holding annual workshop conference, so we can have one session, so etc. Then reciprocal membership, that many people will be interested. So easily we can become a member of other society by paying the 50% of the registration, the life membership fees, and that is a good thing. And presentation at annual meetings. Annual meetings will have each annual meetings will have a separate talk or separate session that we are arranging that one. And basically this is a science, I mean, couple, just like atmosphere ocean couple has enhanced the forecasting length, like from medium to we can go for extended or seasonal with the coupling. So like further that we will enhance our services in this community by joining these two societies. This is the agreement that we have signed by both the president today. Thank you, sir. Thank you, our president IMS and president OSI for this bringing this thing to logical conclusion. Thank you, sir. Yeah. So you can on-share Anand. Yeah. So now we'll go for our chief guest, sir, Dr. M.N. Rajivan, sir. He is the chief guest. As already I introduced about him, and now I'll request on this auspicious day how the atmospheric scientists and ocean scientists should work together to further improve our service capability. So now may I request now Rajivan sir to kindly give the address. Over to you, sir.
Thank you very much. Can you remove this? Can you?
Yeah, no, please unshare it. Exit.
Yeah. Good afternoon, all of you. Dr. Shailesh Naik Sahab, Dr. Nias, Professor U.C. Mondi Sahab, Dr. Mahapatra, Dr. Ravichandran, Dr. Shranay, and other distinguished panelists and also participants of this e-conference jointly be organized by Indian Met Society as well as Indian Ocean Society. First of all, hearty congratulations to both Mahapatra and Ravichandran for getting together. I remember 2 years back when I was attending the Andhra Walter, I think Visakhapatnam Top Mat. I was asking about the ocean community people. I was told that at the same time, the same period, same few days, Ocean Society was organizing the Ocean Society meeting conference in somewhere in Kochi. I was surprised. And I remember that after coming back from Visakhapatnam, I talked to both the president of IMS, Dr. S.K. Darsab, and Sudhakar was Ocean Society president. I talked both of them. I said that this is not the way to work together. Ocean science, ocean and atmospheric scientists work together. And I expressed my disappointment of not working together. And I told that next time when you meet together, you should have a joint meeting, you should have joint discussions, etc. I'm very happy to see that you people are getting together. It's a good beginning. As all of us know that we cannot really think of ocean and atmosphere separately. It's a huge coupling between these two phenomena, these two the components of the system. And we have been using a system, the coupled models for right from weather prediction to climate change projections. And we have even a hurricane weather prediction model, hurricane WRF model, which is a coupled model. So right from the short range forecast to medium range, then extended range forecast, seasonal forecast, then we are IITM is going to start now decadal prediction system. There also we need a coupled modeling framework. Then of course the climate change scenarios which Dr. Krishnan's group is working on with the CCCR models. And so we need both the atmosphere and ocean people to get together, not only scientists and also in terms of science and observations and modeling framework. And we also started thinking about putting new observations, ocean observations. As all of you know that both atmosphere and ocean observations are important, and remote sensing satellites are important for both atmosphere and ocean. And ISRO is helping us to put more and more ocean observations, also ocean satellites also now. And we also started an initiative on coupled data assimilation. Probably some of you may be aware. Under the monsoon mission, we have now started working on coupled data assimilation because that is the new strategy for coupled models now. And kind of a weak data assimilation already being worked out at IITM and at CMRWF now. And WMO even thinking of WMO even started thinking of Earth system prediction. Forget about coupled ocean atmosphere model. They are even thinking of Earth system prediction, which involves many other components of land surface, biogeochemistry, and all this thing. And we members of the research board of WMO now working on to prepare the concepts notes on the Earth system observations, Earth system modeling component, what kind of computing resources you need, what kind of training you need. So WMO is thinking far ahead. They have a large vision, and we also should really catch up. So coupled model is from coupled model we need to really move to the Earth system modeling framework. Coupled model means I mean to say ocean atmosphere coupled model. From there we need to really move quickly to Earth system prediction framework strategy we should do. And we also are aware about the joint collaborative program between India and US in ocean observations. A few years back, under the monsoon mission, we have taken up, and it has given up a lot of good observations and good results, especially on Bay of Bengal mixing of upper air ocean. And then we had a collaborative work with the UK scientists, and especially again over Bay of Bengal, that also has produced a lot of good papers. And now we are in continuation of the earlier existing Indo-US program. We are going to have another program between India and US scientists, and if everything goes well, by this year itself, we'll start that program. That also for which we are earmarked some funds. So the observations, the combined collaborative research observations programs are very important, and we are committed to that. MOS is committed to that. We should do it. And we also are, you may be aware about the India is committed for blue economy, and India is coming up with the blue economy policy document has been already released. It is available in the public domain. And also ministry is coming up deep ocean mission. And so ministry is spending a lot of efforts both in terms of money as well as human resources for ocean. So ocean is a very strategic area now for the coming years. So Government of India as well as Science is aware about that. And tomorrow, I'm frankly speaking, I'm giving a presentation to PM office both on blue economy as well as deep ocean mission. if everything goes well, both the things will be approved very soon. And I wish you all the best for a good deliberation between, in this today's function, all four experts, both two from ocean or two from atmosphere. I'm very sure that the good discussions will be happening. And I request both Mahavotra and Ravichandran to keep this habit of joining together, working together, meeting together. And you can tell the story of ocean to atmosphere people. Atmosphere people are very quick because they're thunderstorm people. The reactions will be very quick. Ocean people may be a little slow, but then they can tell you the stories of thunderstorms and catching up with the thunderstorms and lightning, etc. So you can share the knowledge and experience, and ultimately the country will benefit. We should see that country is benefited. So unless you work together, and I am very sure the last 5 years, 5-6 years, not only ocean and atmosphere, even within the atmosphere community, there was a lot of kind of a disjoin that is now it started moving up, and people are getting together. All three institutes of MOES, atmosphere people are working together. Now they started working with INGOIS. For example, for seasonal predictions, the ocean observations, ocean initial conditions are coming from INGOIS. So we all have to work together. Otherwise, there's no way forward. And I'm very sure that this is a humble beginning which we are starting. And I wish you all the best for good deliberations. And Mahavotra and Ravichandran, if you excuse me, I will leave from this meeting because I have a lot of parliament questions and tomorrow's presentations. I request Mahavotra and Ravichandran to share to chair the further discussions as well as presentations, if you don't mind. Thank you very much.
Thank you. Thank you.
Thank you.
Thank you.
Thank you very much, sir, for your very interesting talk and speech, because you have highlighted how the observation program also should work, ocean atmosphere observation program, and also the ocean data assimilations, deep ocean program, then blue economy. So now it is time to that atmosphere and ocean scientists will work together. And as you suggested, last time also I remember, because there is only one day where both are separated, the IMS function and Ocean Society. Otherwise, more 3 days were overlapping. So we'll see that future it will not happen, and we'll have one session from Ocean Society. In their society, will have our atmospheric part, and like that we'll do that thing. Thank you very much, sir, and thank you for kindly sparing your valuable time for coming and chairing this inaugural session. Thank you, sir. So now I'll forward request our Secretary, Ocean Society, to kindly give the formal vote of thanks.
Thank you, Dr. Patnaik. Respected Chief Guest, our Secretary, Minister of Earth Sciences, President of IMS, President of OSI, Dr. Shailesh Naik, former Secretary MOES and Director NIAS, Professor UC Mohanty, IIT Bhubaneswar, Dr. Satish Senay, former Director INCOIS, Dr. Krishnan, Head Center for Climate Change, IITM Pune, all the members of Ocean Society of India, Indian Meteorological Society, distinguished delegates, invitees, students, my dear colleagues, ladies and gentlemen. At the outset, we on behalf of members of Ocean Society of India and Indian Meteorological Society and the entire community gratefully acknowledge the National Council member of OSI and IMS jointly organizing this National E-symposium and hosting the events on virtual platform on the occasion of World Meteorological Day. We sincerely thank our chief guest, Dr. M. Rajivan, Secretary of Ministry of Earth Sciences, for being with us today to grace the occasion. Despite your busy schedule, sir, your inaugural address was very thought-provoking and has setting the stage for future deliberation. Thank you, sir. We profusely thanks to all invited speakers, delegates, Dr. Shailesh Naik, Director NIAS, Professor UC Mohanty, IIT Bhubaneswar, Dr. Satish Senay, former Director INCOIS, and Dr. R. Krishnan, who are readily agreed to deliver the invited talks in spite of their busy schedule and commitments. Thank you, sirs. We sincerely thanks Dr. M. Mahapatra, President of IMS and DGM IMD, and Dr. M. Ravichandran, President of OSI, Director NCPR, for providing valuable guidance and preparing for today's events and also for signing the MOU between IMS and OSI on this auspicious occasion of World Meteorological Day. This is a big achievement for both the society to work together in future as suggested by our beloved secretary. We sincerely thanks to all the attendees and viewers to take part these events a grand success. Thank you one and all.
Thank you, Jina sir, for your kind vote of thanks. So now with this, we are closing to our inaugural function, and we will now start the technical session that cover 4 talks by distinguished scientists. For that, may I now request our PGM, Dr. M. Mahapatra sir, and President IMS, and Dr. M. Ravichandran sir, President OSI and Director NCPR, to kindly chair this session. Over to you, sir.
Okay,
Good afternoon.
maybe
Once again, sorry. Good afternoon. Once again, I welcome all the distinguished speakers and guests on this occasion. We are really fortunate, I will say, to have a distinguished scientist like Dr. Shailesh Naik, Professor U.C. Mohanty, Dr. Sinesa, and Dr. Krishnan, to have 4 specialized lectures on this occasion of the joint activity of IMS and OSI. So each lecture has the duration of about half an hour, and thereafter we will have some kind of discussions or question answers. I now request Dr. Ravichandran to start with the proceedings.
Yeah, good afternoon. I think I don't want to take much of the time. Just I want to invite the first speaker. For that, many of you know about Dr. Shailesh Naik, but many students and other people are there in this online meeting. So I want to introduce Dr. Shailesh Naik. Dr. Shailesh Naik is currently Director of National Institute of Advanced Studies and Distinguished Scientist in the Ministry of Earth Sciences area. And he was the Secretary to the Government of India, Ministry of Earth Sciences between 2008 and 8 to 15. He provided a leadership role for the programs related to science of climate change, weather services, polar science, geoscience, ocean science and modeling, ocean survey, resources, and technology. Dr. Naik obtained his PhD degree in geology from MS University, Baroda. He joined Space Application Center in the year 1978 and subsequently elevated as a Director of Marine and Water Resources. He was mainly responsible for conceptualizing, formulating, and executing many national level projects related to application of satellite data on ocean color, integrated coastal zone management, snow and glacier studies, and water resources, and particularly development of potential fishery advisory zones. Dr. Naik was Director of INCAIS, Hyderabad during 2006 to 8. At INCAIS, he has set up a state-of-the-art early warning system for tsunami and storm surges in the Indian Ocean. He was responsible for the conceptualization as well as the development of the marine GIS and at INCAIS. He made outstanding contribution in improving various advisory services related to potential fishery zones, ocean forecast, observational program, and ocean modeling activities. Dr. Naik is the chair of the many research advisory committee of many of the institutions of CSIR, DST, DRDO, and MOES. He is a fellow of Indian Academy of Sciences, Bangalore, the National Academy of Sciences, India, Allahabad, the International Society of Photogrammetry and Remote Sensing, and academician of the International Academy of Astronautics, Paris. He has been awarded several what is called honored, and he has been awarded honorary degree of Doctor of Science by the Andhra University, Assam University, and Amity University. He is also recipient of IGU Hari Narayan Lifetime Achievement Award in Geoscience, Vikram Sarabhai Memorial Award in 2012, Bhaskar Award in 2008. He has been awarded Lifetime Achievement Award by Indians by his contribution to the India geospatial activities, by India Geospatial Leadership Award for his outstanding contribution in the development and dissemination of geospatial technology in India. He is the president of Federation of Indian Geosciences Associations, Indian Geophysical Union, Indian Society of Remote Sensing, and Indian Mangrove Society. He was the president in International Geological Congress, the chair, Regional Integrated Multi-Hazard Early Warning System, and also the vice chair of the Intergovernmental Commission Coordination Group of the IOC, and also he was a chair of Indian Ocean Goose and many other resource forum and other things. Dr. Naik was the president of ISPRS Technical Commission 4 on geodatabase and digital mapping during the year 2004 to 8. He has published more than 150 papers in peer-reviewed journals, and he has guided about a dozen students for their PhD, and also delivered more than 200 invited talks in national and international fora. With this brief, I request Dr. Naik to deliver his talk.
Thank you. Thank you, Ravi, for this introduction. Dr. Mahapatra, the very fellow panelist, members of the Indian Meteorological Society and Ocean Society of India, ladies and gentlemen. It's really, I'm extremely grateful to Dr. Mahapatra and Dr. Ravichandran for inviting me to this on the WMO Day to deliver a talk. Greetings to all of you on this WMO Day. I think it's very good to join hands and to discuss about some of the issues which are of common interest. I've been asked to speak on the blue economy. I thought I will just briefly mention what blue economy is. It's essentially ocean-dependent economic development, which we need to do for improving quality of life for people, with the inclusive social development and along with ensuring environmental and ecological security. The term blue economy was introduced by Professor Gunton Pauly, UN, essentially to reflect the needs of growth, prosperity in view of the impacts of climate change. So basically, since in the view of current climate change issues, how we should go forward, and you can see that the blue economy also includes protection of environment as well as inclusive development. So it's not only dependent economic development, but also the social as well as the environmental issues. So this is different than the other economic development. So this, how we should use the ocean, and this is one of the reasons it has been introduced as one of the Sustainable Development Goals, goal number 14, to conserve and sustainably use the ocean, seas, and marine resources. Now, India has committed to blue economy in Nairobi conference in 2018, and this laid a foundation for the blue economy in our country. There is a very interesting observation by our Prime Minister in 2015. He said that the blue chakra or the wheel in the India's flag represents the potential of blue revolution or a ocean economy. This is a very innovative idea that this blue chakra which we have in our flag, which also indirectly represents the blue economy or ocean-dependent economy. Now, there are several issues which we need to address for the blue economy. One, of course, is the fisheries, which is one of the most important component of the blue economy, coastal and deep ocean minerals and energy. Also, the coastal marine special planning, coastal regulations, pollution, which are the other aspects. The hazards, because when you have the development, any hazard will have an adverse impact. So what kind of a response mechanism we have to address the hazard is another issue. Also, there are various international agreements, those exclusive economic zones, CLCS, ICs, International Seabed Authority, and many others. Also, we need to look at shipping, manufacturing and industries, security and strategic issues, how we account for the whatever activity we do and what kind of benefits which we are getting, and also the policy. But I won't be speaking on all these aspects. I will first five only because of the shortage of time. Now, the first, I think we need to understand about the international laws, which is basically defined in the United Nations Convention of Law of the Sea, as called as the UNCLOS. It's a very thick document. We don't have to go into the details, but some of those very important aspects is one is the exclusive economic zone, which extends up to 200 nautical miles from the baseline, and country has a sovereign rights over the waters, seabed, as well as subsoil. India has about 2 million square kilometers under this, and it is very heartening that the almost more than 90% of the work of mapping the EEZ has been completed, and I understand now that the maps will be published very soon, which is the basic maps are the first fundamental thing for development and economy. The second one is the recent, not that recent, but about a couple of decades, this has been started, that the continental shelf also, which extends from the territorial sea, and if it is a natural prolongation of the land, then the country can also have a sovereign rights 350 nautical miles. Of course, your claim has to be approved by the CLCS, and I have submitted the first 0.6 million square kilometer, which is based on a very extensive survey, about 31,000 line kilometers and 90 ocean bottom seismometers. And I'm sure that the second, which may be also around 0.6 per million square kilometer, would be submitted soon. So essentially, you can see that our land area is about 3.2, and we will get ocean seabed also about 3.2 square kilometers. So it's a huge area which is required to be explored, surveyed, and whatever the resources are there, they have to be assessed, and which can lead to major economic benefits. Apart from this, there are crises which are beyond natural jurisdictions, but we can get exploration and exploitation rights through International Seabed Authority, and India has 75,000 square kilometers under for polymetric nodules and 10,000 square kilometers of sulfides. So this is the basic thing which India has extremely good database on these aspects. Now, the first is the coastal pressure minerals. We have abundant coastal places, especially on Kerala, Tamil Nadu, Orissa, Maharashtra coast, and on the coast as well as in the near shore. And we have a huge reserves of ilmenite, rutile, garnet, zircon, kyanite, sillimanite, magnetite, monazite, and many others. And ilmenite is one of the very largest uh, reserve which we have. Now, this has been identified as a 5 minutes by 5 minutes blocks for exploration. The total value could be about 150 billion. Unfortunately, there are some issues. So still, it has not been claimed by any private parties for further exploration. But the initial amount, the survey which is done by GSI, Atomic Mineral Division, and NIO, has said that the huge resources available. Also, some of the mining techniques development also has happened by the mostly CSIR institutes. The deep sea minerals, the polymetallic nodules, which is very well, almost first mining site also has been identified. And it has 380 million tons of various polymetallic nodules. The total value is about 187 billion. Also, the BA beneficiaries and processes have been developed, and almost 95 to 97% metal has been recovered. Similarly, the polymetallic sulfides, the major exploration has been initiated, and now some of the vents have already been identified. The detailed further work is being undertaken by using various submersibles and many other things. The third, which is very critical, is the cobalt, and which is, very much essential for us for electronic industry and also part of strategic importance. We don't have much cobalt on the land, and this is available on the seamounts in the Indian Ocean, and I think we need to get the exploration rights for this cobalt as well. The energy, one of the very major, of course, all oil and gas comes from the ocean, but there is another resource, which is a gas hydrate, which is between gas, which is under pressure, gets solidified and forms like an ice. It is available in continental margins, especially on the Bay of Bengal. The total volume is about 1900 tera cubic meter, and even 10% if we can recover, it would be last for about 100 years. So we have huge resources on this, and NIOT has been developing numerical models, how we can extract the methane gas. ONGC has already completed crude drilling operations, and in Mahanadi and Andaman, they have identified two very rich beds. So this is an area which is a very future resource which may be available in another decade or so. There are many renewable energies. I won't go into details, but the offshore wind energy has a huge potential. And in fact, identified about 61 gigawatts of power can be generated. The first 1,000 megawatt farm is being planned in Gulf of Khambat. Currently, the cost may be a little higher than what we get from other renewable sources, but I think initially solar was also expensive, then later on it became very affordable. But the issue is also you need a very specialized infrastructures if you want to set up offshore wind farms. The kind of vessels to install the huge turbines, the port facilities. Also, you need a forecast of zonal winds and meridional winds at 50 meters, 100 meters. And I understand this is already been accomplished. So this is one area which I think will be taken up very fast, and large amount of power can be generated from the offshore wind farms. Similarly, there are experiments going on to generate energy from wave, ocean currents, and thermal energy. One very interesting is about the biofuel, the experiment which has been done by NIOT, and what is called in technical terms the B10 biodiesel was prepared from chlorella vulgaris, one kind of an algae. And this is found to be a very easy to, it has a large amount of fatty acids, so you can get oil. And this, the one Innova car was run for somewhat time using this biodiesel. Now the issue is that how to scale it up. So though the field laboratory experiments are quite successful, the major thing would be how to scale it up and how we can generate large amount of biodiesel from the earth. All this development also needs a lot of technologies, and the soil, first most important that you need the characteristics of the soil, because whatever instruments or equipment you want to design will need the information about the soil. So this has been developed and tested and provided data on the soil properties. We have also the remotely operable vehicle, which can have 150 kilometers of payload. So you can take photographs, you can measure various properties, the oxygen or whatever sensor you put, all those can be measured using. This also has been tested up to 6,000 meters. The crawler with mining has been now in the development stage, and it was only about 1,100 meters. But I'm sure that under deeper space, all the instruments will be further operationalized. This is very important that coring, especially for the gas hydrate and many other things. This has been now developed, which can take core up to 100 meters in 3,000 meter depth, which is very unique capability to have such things. There are very few instruments of this kind in the world, and I think this we need to further improve to at least up to 250 meters, because the gas hydrate occurs in first 150 to 200 meters. So we should be able to get core up to 250 meters to assess real capability of the gas hydrates. This is one of the very innovative and very successful programs where the low temperature thermal desalination used, and it's very simple in practice, but very difficult engineering wise. The seawater is brought to a chamber, in a vacuum chamber, and allowed to evaporate. And the another chamber, it is collected and it is cooled from the water brought from the ocean around 800 to 1,000 meters. And you get absolute fresh water. There are 3 plants that have been working for last 15 years or so. Another 6 plants, I think one more plant is ready. 6 more plants are being done in the Lakshadweep Islands. And I must say that this is only this kind of plants are in India were able to really convert this idea into an engineering. And this can be very well exported to all such islands like Maldives, Seychelles, Mauritius, Caribbean islands, also some of the Pacific islands, where the water is a major constraint. The current method of RO is a lot of environmental pollution, so this is much better. And recent meeting in Niti Aayog also, it was agreed that this is the technology which should be further encouraged. And now I think we also need to scale it up, whether to liters per day, whether we can generate that it can supply water to large cities. The next is the living resources, the fishery, especially the pelagic fishery. One of the most important things which we need to do, some of the experiments has been done, that what is the annual stock available, likely to be available. And as we get the annual, before the harvest, we get rice, paddy, wheat, that this is the likely production. I think for fish also, we need to build a system that before the season starts, we know how much potential is available. And once we have that potential, the strategy for fishing can be planned accordingly. So this is, I understand the work is in progress, but I think the actual model and real prediction is still a little bit away, but we need to do this as early as possible. Of course, this is a well-known application been doing for last 2 decades very successfully, and this about 4 billion people which are dependent on marine fisheries have got benefited by this. Our potential yield is about 5.31 million tons. And we generally, around 3.8 million tons only is harvested. So mostly we are harvesting within the biological limit. So it is not this forecast is not providing, allowing any overexploitation, but it only provides an efficient way of fishing. And this is very useful because it leads to reduction in search time and increase in catch. So all this together, the annual economic benefit is about 7 billion. And recently, I was told that each trip, the fishermen are getting benefited by about 17,000 rupees. So it's quite beneficial to the fishermen. At the same time, we are investing our deep sea resource. We have a very high abundance of a deep sea fish, especially the big fish and shellfish, the various ground around Mangalore, and they have been found. And this needs a development of a technology for harvesting as well as processing them on board. So this is one area which is very important for us to address and focus on. The potential could be 3.3 billion tons. So it's quite huge. It can add another 60% of our potential. So it could be an extremely good resource for the income generation. There is another major resource which have been found, is called nitrofit, and this is available in low oxygen zone. Of course, this is non-table fish, but because it's a very high fatty acids in it. So, but this could be used for a feed for the brackish water aquaculture. So this is also an area, and the potential is huge. 100 million tons is huge potential. So this also needs to be further pursued. A lot of technologies have been built about the ornamental fishery. One is already on the clownfish, is already being done by the women's cooperative. The NIUT also has built on the cage culture, cobia and milkfish, which also generated extremely good catch, and within about 11 to 12 months. And fish can grow very large, about 4 kg to 700 kg. The black pearl technology CFRI has been trying, and in lab it has been generated, but still it is not at a production level. It is still a lot of work needs to be done before this becomes operationalized. Now, all this also it's very important for us to understand that what different kinds of species are available. And this is also useful for the drug discovery. One of the major CMLRE is Ocean Biogeographical Information System, which provides the information about all the species which they have been surveyed, and that along with the location, the huge database has been created, and this is absolute. And anybody who wants to see if this data is available. And this is very useful for a variety of things to understand the genetics, its morphology, occurrence. And also, if you repeat this survey, it will also tell us whether there are any changes occurring with respect to climate change or anything. The last part is the coastal marine spatial planning. This is, it is basically to specific issues which we need to analyze. Though we are not doing everything under this head, but India has one of the very good system, what is called as the coastal regulation zone. And this is to regulate all activities, and the entire country's coastal zone management plan are available. So this is a very good database. Over last 30 years, the repeated database has been created, and this could be one of the major sources for our planning to what we should do on the coast. So this kind of maps are available for the entire country and on different themes. This is another major service which is being provided on coastal ocean state forecast at the different levels, right from global to Indian Ocean to Arabian Sea, Bay of Bengal, as well as some of the ports. 3 to 6 hourly forecasts are provided. And this is extensively used by fishers, navy, ports, harbor, and one of the very important service is being provided to all seafarers. Cyclone, of course, one of the very success stories, which we provide the track, landfall time, everything well in advance. Also, along with this, the prediction of storm surge as well as inundation is also, and the high waves is also provided. So basically, any impact it would have on the coast, so you have about 5 days time to respond to such things. The tsunami is again a major service which is been available, and this is unlike US and Japan. We are providing the information on every 50 kilometers. That means the what we call as the coastal forecast point, not basin wise, which is given by Japan and US. So we are providing forecasts at 1,800 points all along the Indian Ocean, so that, and this is completely automated system. The first email goes within 6 to 8 minutes, and then it is followed up by the experts routinely as and when required. And the coastal vulnerability for the all kinds of hazards, this kind of maps are also available on 100,000 scale prepared by employees. And I won't go into details, but very methodical. And this maps have been prepared, and this is one of the most important contribution for the country. Recently, some of the beaches have been given tag of a blue flag. This is a certification by the autonomous agency in Europe. This depends on how safe beach is, what is the water quality, etc. So 8 beaches now have been identified as the blue flag beaches, and this was inaugurated in this season. So this certification has to be done every year. So they have to keep monitoring all the aspects of the beach, and this is very important because this will attract a high value tourist to this regions. Now, the beyond 2030, if we want to progress, we believe that unless we make large investment in ocean and coastal environment, it won't be possible. So considering that deep ocean mission, all of you know, has been already announced, and there are different components which will give further boost to the blue economy. one of the most important aspect is the data, and Invoice has organized the data very well. Now, the issue is that this ocean data, scientific data which we have, we need to integrate with the environmental, social, and economic data. So this is one of the most important things which we do to find out that how the importance it has to the economy and what is the societal relevance of this information. So we need to now start integrating this data with the social and economic data. I think that is one area, and this is a very big challenge because the formats are different, everything is different, but we need to sit with social and economic economists so that we can integrate this data. The is
I think some poor connection, sir.
Yeah, we are not able to hear this.
I can hear, but you cannot hear, eh?
Now it's fine, sir. Now it's fine, sir.
Fine. Okay. So the institutional framework is critical, especially governance system of the blue economy. I think we need to do some work, research on the governance system of the blue economy is very necessary. So I think in the end, I would like to say it should be managed as a valuable assets for the sustainable growth. And lastly, this is what long back, 30 years back, this was said and relevant even today, that how inappropriate to call this planet Earth when it is clearly ocean. And I think in future, we are all going to depend on the ocean more and more. Thank you very much.
Thank you. Thank you, sir, for your very illustrative aspects of blue economy, starting from the issues and opportunities, both living and non-living resources, and technology aspect, and many other areas, what we need to do, and also way forward, like institutional mechanism, how to do that. I not find any questions from that. One question from the audience, just I think this is from Aditi. There are already few international studies that shows the hazards of deep sea mining and deep sea fishing. How will ocean conservation be addressed and honored in the blue economic policy?
See, basically, this is one area where the first thing is done is to collect the environmental data before any mining starts. And the same thing is being done already on the environment. Large amount of environment data is already been collected. A lot of models have been done that what kind of impact it could have. And this will be done as anywhere else. And I think there are a lot of information already available. I understand the whole book has been published recently about the environment related issues. So that is, I don't think, a major issue. The blue economy will ensure that the ecology and the environment is preserved along with the social development. So that is the goal. And I think I don't see any reason why it cannot be done.
Thank you, sir. Thank you, sir. I think maybe we can summarize later. At want of time now, we will go to next speaker. Thank you once again, sir. Thank you for your. Dr. Mohapatra,
Yeah.
over to you.
Yeah, thank you. Thank you, Sarasnek sir. We'll go to our next distinguished speaker, Professor Umasarana Mohanty. Does not need any introduction, as he is worldwide known as a distinguished scientist in atmospheric science. He has been associated with many new initiatives in the field of atmospheric science, and there has been acknowledgement to his credit. Currently, Professor U.C. Mohanty is the Emeritus Professor at the School of Earth, Ocean and Climate Sciences of Indian Institute of Technology, Bhubaneswar. He has been associated with many organizations. We are feeling proud to inform you that initially Professor Mohanty joined India Meteorological Department, and thereafter he went for higher studies in USSR. And after coming back, he joined as a professor in Indian Institute of Technology, Delhi, in Center for Atmospheric Sciences. Thereafter, his journey began in terms of the accomplishments, achievements, and awards. He received many awards and recognitions, including the fellowship of all the 3 academies of the country: National Academy of Sciences, Indian Academy of Sciences, National Academy of Sciences, Indian National Science Academy, and also National Academy of Engineering. He has been awarded with Shanti Swarup Bhatnagar Award for his contribution in the field of science and technology, especially the atmospheric sciences. He has received many awards, including MD Deshpande Awards. He has got the Silver Jubilee Awards for aeronautical research and development. He has received Samant Chandrasekhar Award from Odisha Vigyan Academy, Sir Gilbert Walker Award, National Award for Atmospheric Sciences and Technology from Minister of Earth Sciences, and he has been the senior associate of International Center for Theoretical Physics. He has been associated with many associations and organizations in the country. There will be an infinite list if I go on listing all his achievements. I just want to mention that in the field of numerical weather precision modeling in the country, he is one of the first pioneers in the country to start with the numerical modeling of atmospheric sciences. He has been very enthusiastic in the beginning of this exercise being taken off by the then Department of Science and Technology towards the establishment of National Center for Medium Range Weather Forecasting. He joined there as a deputy director, and his contributions are to be remembered for the ever. He has been a good teacher, ideal teacher, and he has produced a number of PhDs. And I am fortunate enough to be his student. I got my PhD with his able guidance and leadership. He has published more than 200 research papers in various national and international journals. He has been the man behind the various kinds of forecasts being introduced in the country. He has been the man behind the major research projects being taken up in the country. I will just mention a few. One of the most important research which he took up is the extended range forecast for agriculture. It was a big project taken from the Ministry of Agriculture and accomplished by Professor Mohanty, and the model was handed over to India Meteorological Department. He has been pioneering the forecast demonstration project, especially the mesoscale weather events like thunderstorms, squalls, hails, etc. And it was a successful event. Whatever you see today, it started almost in 2006 with his able guidance and leadership in front of the project. He has been associated with other severe weather events to mention here. Cyclone has been his core field of research and development. With him, there have been a number of people who have been involved with research and development in the field of tropical cyclones. And because of his contribution to tropical cyclones, new findings, new results have come up, which have been utilized in various regional models and global models. We are fortunate enough here to have Professor U.C. Mohanty to speak to us about the recent advances in the tropical cyclone research and its contribution in the country. Thank you very much, sir. I welcome you now to deliver your address.
Thank you very much, Dr. Mahotsav. Very good afternoon to everyone. Dr. Salesh Nayak, Director Nias and ex-Secretary MOES, Dr. Mrutyunjay Mahapatra, Director General IMD and President IMS, Dr. Ravichandran, Director INCOR and President USI, Dr. Sinoi, ex-Director INCOES, Dr. Krishnan, Director Center for Climate Change Research, IITM, Dr. Patnaik, Dr. Jena, all the distinguished participants of today's webinar. At the outset, I heartily, my hearty greetings and congratulations to all on the WMO Day. And in that respect, it's a very auspicious day for the all meteorological community, and now also it is for the ocean community as well. And because these two branches of science, always I feel that science for the common man. And this is science which is needed by everybody, starting from a beggar in the street to a president or king in the palace. Because everyone needs the information about weather and climate. And in our planet, when we see, it is possible because of the water. That's why when we invade any other planet, we see whether water is available or not. And 97% of our water resource is in the ocean. So obviously, all our weather and climate processes, which is driven with the water vapor and clouds and the weather, they are the origin from the ocean. But if we see the origin of the atmosphere and ocean, which is past, it is just like chicken and egg, but our atmosphere is 1.5 million years, 1.5 billion years older than the ocean. So in that way, atmosphere is big brother of the ocean, but they are coexistent with each other. And this is a good auspicious day also in India. We have signed such a good MOU between IMS and OSI. And as I told, I am going to join as a first day member in this society, and I told to Dr. Jena that I will join society as a combination of IMS and OSI. So today I am, and also at the outset, I thank to Dr. Mahapatra and Dr. Ravichandran for kindly inviting me to give this lecture, and I am very thankful to them. It is a privilege to be associated with this activity of both the society coming together. So today my talk is in advances in prediction of tropical cyclone over North Indian Ocean. Actually, I was basically completed my degree in physics, as nicely told by Dr. Mahapatra. But I was actually from very childhood was influenced by the tropical cyclone because I belong to a coastal region, and from very childhood we are hearing so much a tropical cyclone that whether will we exist with that or not. Because you know that very infamous cyclone, Odisha super cyclone of 99, where actually more than 10,000 people died in and around of my village. So with that initiative, I joined actually about 50 years back in 1971 in meteorology as a child in a meteorology, where I know the word meteorology from a dictionary. Though we know atmosphere science, but meteorology, just we are knowing that time. So with this, actually, I start my talk. I acknowledge several organizations and individuals for this talk, which I'm going to present today. This is for the Ministry of Arts, Sciences, MOA, Agricultural Department, Indian National Science, INCOES, NCET, HRD, Hurricane Research Division, Purdue University, National Center for Meteorology and Weather Forecast, IITM, and a group of my young colleagues who joined with me at several stages as students, and they are eminent scientists of their own, like Akhilesh Gupta, Anand Das, Sudhata Krishna, Raghu, Sama, and so on. And I am also thankful to IIT Delhi and IIT Bhubaneswar for giving me enough opportunity to carry out my research work. So for the sake of everyone, I just give a very brief introduction about uniqueness of the North Indian Ocean. Hopefully all of you know that we have two cyclone seasons. One is the pre-monsoon season like April and May. Another is the post-monsoon season, October and December. It is unique. No other basin. All tropical basins are conducive to tropical cyclones, but Northern Indian Ocean, that Bay of Bengal and Arabian Sea, these two basins, they have two cyclone seasons. Cyclones are relatively moderate intensity as compared to other basins. Cyclone's lifespan is 3 to 4 days over North Indian Ocean because of the two days or seas both sides, and it passed through very fast, not like other basins like Pacific or Atlantic, where the cyclones exist for 7 to 10 days or even more. And these two basins contribute only 7% of the world total cyclones, but the highest number of human casualties found in this basin, with very infamous Bhola in 1970, where 3 lakh people perished in Bangladesh, and recent cyclone Mala, where actually Myanmar, about 1.5 lakh people also perished. Large stress of low-lying delta regions in the cyclone-prone east coast of India, with the presence of a relatively large number of river systems, are main reasoning for coastal inundation, low-lying areas, and certain segments of Indian coast are highly vulnerable to storm surges due to shallow bathymetry. So this is what it shows that we have two tiny basins of Bay of Bengal and Arabian Sea. Bay of Bengal, number of radial cyclones having more than 10,000 casualties. Bay of Bengal about 24, Western Pacific is 7, Arabian Sea 1, and Atlantic 1. This shows that how vulnerable this Bay of Bengal as the casualty is concerned. And this is the basin where the cyclones, they may cross Myanmar, Bangladesh, India, and sometimes also Sri Lanka. The potential damages associated with tropical cyclones, this is a low pressure region, a large pressure gradient, strong wind, and convergence of mass, heat, and moisture. So that lead to strong winds, storm surges, and heavy rainfall. So all three are very potential for damaging the coastal regions. And in fact, actually, earlier, these type of cyclones, we are feeling that they only affect 5 to 10 kilometers coastlines. But after 99 cyclones and this recent Fani of 2019, we saw that even the cities like Bhubaneswar, Cuttack, which are far away from the coastline, maybe 40, 50 kilometers away, but they are also very severely affected. Like last Fani, Bhubaneswar was cut off without power and water for about a week. But this type of events were not so much in past. And this is more found with that of the Odisha super cyclone. So there may be some link of climate change and penetration of these extreme weather events from the oceans to that of the to coastal cities. So in order to actually increase in the quality of prediction for tropical cyclones is one of the demand all the time. And as you know that as it is told by in the introduction by Dr. MAHOTSAV, ocean is the cause of our monsoon, southwest monsoon. It is also thunderstorms because they are seen this land sea breach and tropical cyclones. And previously, people are so much worried for tropical cyclone, and they're telling you that because the death was very enormous in the coastal area. But now you will see that last few years, it has substantially decreased. And because actually if we see the system of increasing the quality of prediction of the tropical cyclones, then we need a chain of activities, detecting and tracking of rain cloud clusters from which damaging windstorm grows. That is now very much possible with the satellites, satellite eras. Prediction of cloud cluster developed in a storm with sustained wind of gale force. Prediction of a growth and strengthening of cyclonic vortices. Forecasting the movement and landfall of storm centers as it possible as it approaches coastlines, and prediction of storm surges and coastal inundation associated with the movement of the tropical cyclone. In this link, though the last one is the most damaging for the Bay of Bengal, the maximum casualty occurred due to storm surges and coastal inundation. But most important aspect is the forecasting correct positions of landfall and the intensity of the tropical cyclone. Therefore, most of my talk will be focused on this aspect and how well India has approached and where India stands today in the prediction of tropical cyclones. So I will try to go it in a very vast topic, and we have short time, but I will try to pass through quickly and showing you only the glimpses. So the prediction of the tropical cyclone means a track at the vector motion of the storm, place and time of landfall, duration and time of the landfall, duration of the storm, track of the cyclone storm. Intensity, which is equally important for the tropical cyclones, that is central pressure, pressure drop, maximum sustained wind, and rainfall as with the tropical cyclone. The various methods are there in prediction of tropical cyclones. Of course, it started with very simple synaptic methods with which even we are using extensively now also. After that, when numerical methods are not there, persistence, climatology, statistical methods are well developed. Then after that, started dynamical models, and ultimately we have combined dynamical statistical models, ensemble prediction system, tracking probability forecast, and also coupled land, ocean, atmospheric models. So the advancements that which have done in India is analyze that. So it is mainly because if you see the progress of the, I will show you subsequently the IMD2 view graphs that is the dramatic improvement in the prediction of the track and intensity of the tropical cyclones in recent 15 years or so is very much coincide with the establishment of MOS and modernization of IMD observation system. Observation is main backbone of the weather science, and it is not only observation of the atmosphere as well as the ocean. Now we are very proud to have a coupled model for the Indian Ocean, and thanks to the Argo system. Because before that, which is 15 years old or so, because though it started in 99, but it is well established by 2005 or so. Before that, we could not expect to have ocean data to use in a short-range prediction to have a coupled model, even for prediction of tropical cyclone. And now it is possible. So it is only thanks to the observations by various means, satellites, remote sensing, and surface-based and space-based observations. Then other is the establishment of Earth System Science Organizations, USSO, and coherent R&D between these institutions of MOS, which thanks to go to the Dr. Silas Naik, who is here, who put a lot of efforts to bring all these sister organizations of Earth System Science Organizations to work together in a single goal to take the science to the common man through improvement of the prediction systems. Then started a FTP of tropical cyclones in the year of 2007 or so. And I remember actually the remark by the then secretary, like how we are using very old models and switch over with very advanced models and so on, and close interaction among the operational, academic, and R&D organizations through FDP. Strong international collaboration and technology transfer, mainly with NOAA, that is NSAP and Hurricane Research Division, establishment of National Disaster Mitigation Authority in 2005, and State Disaster Mitigation management authorities of different state governments, and who can translate the forecast of the IMD to at the ground, evacuate people of 1 million to 1 million to 1.5 million in short notice. And collaboration and upgradation of HPC at MOES institutions for improvement of forecast system through monsoon mist. These are some of the aspects which could lead to the present day fruit we enjoy, and we now no more fear a cyclone will be really devastating for the coast, because the death toll is only 1 to 2 digit numbers, not 4 digit, as it was in 99 or even in Myanmar in the year 2008. So this you can see actually this cyclone prediction of 99 versus that of 2013 falling. In one case, the casualty that the official record about 10,000 to that of the falling or most similar intensity casualty about 20. Out of that, about 10 or 12 due to floodings, and cyclone was less than in 1 digit only. But thanks to the 5 days in advance prediction, this is just a animation I am showing, 5 days in advance prediction of this cyclone Tallinn, which crossed the Gopalpur. So this is the track errors and intensity errors. This is the IMD operational forecast for the period from 2003 to that of 2014 and so on. If you can see that there is a gradual improvement, and a lot of improvement have made in the prediction, both in the advance in time and also intensity prediction. Similarly, landfall position prediction has substantially reduced the errors, and landfall time also has substantially reduced, so that this helps the people as well as the planners and disaster managers and disaster management authorities to make a large-scale evacuation process from the coastline to save the life of the people. If we see mesoscale models for the predictions, so as I told the history of the prediction of the tropical cyclone, if you see in 1980s or so, we have statistical models. And then we have a simple barotropic model, which is used for the sample prediction. Then we did late Dr. Professor P.K. Das and his team. And that time they used a simple barotropic model. Then started the quasi-Lagrangian model in 90s and MM5. Then came WRF, which came of course with MOES and so on. Then SWRF, and now SWRF with the coupled hurricane with the forecast model coupled with the ocean, Indian Ocean. Until 2003, forecast methods were subjective at IMD. Course resolution quasi-Lagrangian models providing track guidance up to 24 hours. Now actually the forecast is up to 5 days and with striking potentials, so that you can see that how much it is improved. So this is a forecast comparison between the MM5 and WRF, which was made in that year of 2005 and 6 to replace MM5 and WRF, which WRF actually released in 2005 and India adopted in 2006 and 7. In 2006, we have a extensive training to Indian communities by IIT Delhi, and the model was implemented and operational also from 2006 and 7. So these are the cyclones at that time passed through the Bay of Bengal and Arabian Sea, and this is the WRF versus MM5. I'll not take time for that. And about the configuration of these two models, at that time it was 27 kilometer resolution. And this shows that in all those cases, it is clearly evident that the WRF is better than MM5 by about 72%. The mean error was 153 in MM5 versus 88 kilometers in WRF at that time. Similar landfall time error also reduced. Then actually with FDP, lot of experiments are done with the WRF model, and there's a large number of cyclones that are examined, and they are
I'm
there's
going to
also
close everything. I will close everything and restart.
it is not visible. Hello? Hello?
Because you
It is visible, sir. It is visible.
Yes, sir. It is audible.
It
Is it audible also?
Yes, Professor.
Yes, yes.
Yeah, somebody told that he close and he restart. That's where.
Yes, sir.
That is something different.
That's it. So
We can-
then, in fact, as I told you all the time, the improvement in prediction intimately linked with the observations. And as you all know that now we get maximum observations from non-conventional methods. So non-conventional data utilization is one of the important aspects in data assimilation, where actually now NCMW is making a very lead role in utilizing Doppler radar and satellite data assimilation and so on. That is one of the most important aspects also in improvement in the prediction of the track and the intensity of tropical cyclones. And here actually I show very briefly the impacts. So this is the impact I'm telling in the respect of the satellite data utilization, which is several cyclones. And this is the mean vector displacement error. The red one is without, control one without going to 3D with satellite data assimilations, and the blue one with the data assimilations. Then you can see the all scale starting, though we have not much improvement in 12 hours, because that is mainly due to the initial position errors, which is about 50 kilometers or so. But as you see, gradually the improvement is more and more. And in the 96 hours, 4 days, the improvement is substantial. And that percentage is 24 hours, 22%, and 96 hours, about 47%. The improvement only by using these 5 cases, Nargis and Gono cases. But similarly, the Doppler radar, coastal Doppler radars, we have a large number of coastal radars now. I am showing a few example cases like Doppler of Calcutta and Chennai, which are extensively used in those times for the cyclones of the 2007, 9, 10, 11. But a period like that, where actually extensively used, and the improvement that shows is also quite substantial. Though actually it is a coastal area, still then that is what drives the flow with satellite and Doppler radar. You see that the improvement comes as large as you can see here. The initial time control run with the DWR, control run with the GTS, and the GTS versus the DWR and satellites. So you can see that the improvement is as high about in 24 hours, it is about 25% and 65% in 72 hours. The improvement is about 65. Similarly, this is the case of the forecast high length and the track errors and intensity errors in 2003 to 2011 period. And you can see that at that time, 24 hours forecast was about 140 kilometer without assimilation, 119 with assimilation, and 95 kilometers assimilation, 9 kilometers resolution. So that gradually improved with 48 hours and 72 hours. It is compared to 176 compared to that of the 375 kilometers. Then near real-time assessment of the HWARP versus WRF. Then HWARP came into field, though it was actually introduced in India also again 2007. And this was a collaboration between the NOAA and MOES, and particularly IMD, NCMW, IIT Delhi, and few more organizations of MOES. So with that, HWARP system came to India, and it was became installed for operational use in 2010. And this is the assessment of 2013 to 17, the HWARP versus WR systems, which show that, again, the same story, that the HWARP is superior to WRF though it is not so much in track or almost comparable with less improvement, maximum improvement is the intensity prediction. Intensity prediction will dramatically improve with introduction of HVAC system into operation center. This is the 10 kilometer wind speed in knots. Then you can see actually gray one is W1, WRF, and the black one is the H1. Then you can see that about 120 hours prediction. The difference is almost half the errors. You can see the last one, 144, 114, then 200, 120 hours. That's 5 days for part. But 10 meters wind has reduced substantially the error. This is the forecast length and mean intensity errors in root mean square errors in knots, and you can see that it has dramatically improved with the introduction of the HVAC system. And the RMSE of HVAC intensity is 20 knots, while it is 30 knots for WRF up to 96 hours. Comparing individual TC cases, it is realized that stronger TC are underestimated and weaker TC are overestimated by the WRF. So this impact of assimilation, again, pole initialization and cyclic initialization, anyhow I'll skip that one, but you can see that that also improve the vortex or very severe cyclones more accurately when we go to cyclic type of which is generally used in the operation setup, but in the research setup, generally the pole condition taken as a, because every cyclone is taken as individual. So this is the improvement in the tracks, and this is the two cyclones which I'll show you of 2013, because after 1999 Odisha super cyclone, next most intense cyclone was that of the Cyclone in 2013, to really to test how far we are progress are there in that period of 14 years. You can see that this Cyclone cyclone prediction, and same year we have a Leher cyclone which crossed the Andhra coast, and they are actually very opposite to each other in the sense one cyclone sorry, this is the recent successful NWA models. So this is the wind speed, that is IMD observation control, and inside 3D, 3DR, you can see also that the wind speed at 10 meter, that also quite improved. Data and hour of November 2018, that the mean intensity error also substantially improved. Successful annual models prediction in the recent tropical cyclones. So this is the cases of Bay of Bengal cyclone. One is that only of last 2019 case, and where actually you can see that the prediction was made very successfully up to 5 days, and same way also the intensity prediction, the black one is observed, and the red one, that is what is predicted. With different 12 hours interval, the prediction and that is generated at IIT Bhubaneswar and provided to IMD on almost real-time basis. And you can see that it is just like a textbook. The prediction was quite accurate. And now, actually, as I told you, that this is the cyclone of the Amphan, which was a super cyclone of the 2020, last year, the 2020 cyclone is also predicted extremely well, and not only the cyclone, also its intensity. So again, this is IMD official forecast where the striking potential is given, so that it will give a warning for the area which is likely to be affected. And this is the comparison between HWRF and WRF models, with the forecast length for the mean track errors, and the blue one is the WRF and the red one is the HR. Then you can see that it has a substantial improvement has passed with the time. 96 hours forecast, you see 96 hours, 72 hours, and 96 hours, you can see that a large improvement you can see with the HR system. And so also the intensity, though WRF model could not show the intensity as strong as actually occurred with a super cyclone Amphan, but WRF predicted and 10 meter wind, and you can see that the HR is red and blue is the WRF. You can see that the intensity also predicted very well with HR system. And some of the ongoing and future research activities. So here actually one of the most important, though track is predicted very well, always we have the question is the prediction of the intensity of the tropical cyclones, because that which lead to the damage of coastal areas and loss of the lives. So I show that the system, HR system, how it predicted both rapid intensification of the cyclone Helene and the rapid weakening of the Leher cyclone. And because IMD was very accurately predict the Leher cyclone, though it was intense cyclone in the bay, and by the time of landfall, it was substantially weakened. And that is also equally important because it brings up faith in the people to believe the forecast whether to evacuate or not. Because if you wrong forecast once, then people lose their faith because evacuation is not a such a happy situation. People have to face that because when it is a very severe cycle. So both Helene and Leher, you can see one is rapid intensification, rapid weakening, and this is what is observed, mean sea level pressures and the wind speed. So you can see that the Leher case it weakened much faster, and Helene is intensifying much faster, and pressure drop is quite large, and then wind speed also increases. So this case was, both the cases were simulated with Leher, with HR and Helene, and it has found that in case of the Helene, the vortex, the core of the vortex, you can see that it is a straight line and it is the intense one, but in case of the Leher, it was tilting. And most important is that this is the trajectory of the air mass. And you can see that the penetration of the dry air mass, cold and dry air mass to the center of the layer, which could weaken in that case, and compared to the Helene, which was intensified with not that type of motion. And this is the this shows that the moisture and the time and height cross section of the temperature anomaly plots along with that of the wind and water vapors. Then you can see that in case of the Helene, due to the large condensation processes, warming is taking place and the flow is intensified as we move in the time. But here you see that you have a dry air in the middle of the middle troposphere. In the case of Leher, which actually gradually descended down and tried to weaken the Leher case substantially. And this type of understanding could come very well from that type of modeling of HR systems, which is used in this case to see that the process of intensification and weakening. So these things actually lead to us that we to examine now the case of the impact of the SST, because we are previously thinking SST can be kept constant and what is the role of ocean and so on. So we have done several experiments to see that we change the 6 hours, because as I told you, with the Argo system and with the assimilation of the ocean parameters by INCOES on the real-time basis, now it is possible to go to real-time basis prediction using the ocean assimilated data. Otherwise, previously it was not, it is a dream. Actually, I know that when in this is our ocean DOD was there, and that time they started a ocean modeling program, but we don't have data. It is in late 95 to 99 or so. But after the Argo system came and so on, it was possible that we have ocean assimilation on the real-time basis, though it can be used also to see the impact of the sea surface temperature on the intensity of the cyclones. That we have tried with several cyclones, and it is so that there is also, if you not take a fixed SST, but you go on varying the SST, and this is all handcast mode is there, but then we have gone to real forecast mode also by a couple model, but this is the handcast mode which clearly shows in most of the cases that there is an improvement of 40% average improvement in intensity which will get by SST. Though track is not so much difference, but intensity it has a big impact due to change of the SST, because SST itself actually changes very fast when there is a very severe cyclonic storm with a lot of evaporation and cooling. Then we have tried with a idealized HICOM system, which is linked to a dwarf system, to see that what is the impact of this type of ocean on that of the climatological experiments, so that modest difference in the prediction of maximum intensity. Maximum intensity is strongly related to SST of the inner core and is more strongly related to enthalpy flux average of the inner core region. So then actually this is a couple model system where actually this is a joint efforts of IMD, INCOES, and IIT Bhubaneswar. The three groups jointly try to work on the couple ocean model of for predicting very short time scale of the tropical cyclones. And this is a post study of cyclone Oki, which was known that he passed through Kerala coast and he fall over the again Arabian Sea and intensified. And this case was simulated very well, which track of this cyclone that you observed. IMD1 is the black one, and a coupled one is the red dot, and uncoupled one the blue one. And this is intensity prediction. And intensity prediction, you can see that actually it is which the coupled one, it is showing much closer to that of the observed, and which was not found in the uncoupled one. UCP, the uncoupled CP, the coupled, then you can see that coupled simulation is very close that of the solid line, which is observed one in the topmost figures, and you can see that it shows that coupling has a lot of good impact for the cyclone to predict its intensity. And this is the case of the funny. Again, this case also, it is carried out with the coupled and uncoupled systems, and this also shows that there is a lot of coupled ocean atmosphere simulation of TC, SI and TC funny, so that average improvement for coupled case has moderately improved in both track and intensity. More cases are required to see these things. And other thing actually being, we have so much improvement in the intensity of the tropical cyclones. Now instead of projecting the idealized, yeah.
Sir, you're getting delayed, sir.
Okay, I'll close here. Ideal things, we can take also intensity of the 10-meter wind as an input for the prediction of the storm surges associated with the tropical cyclones. And this is one-way coupling, of course, a one-way coupling of HOR wind fields with that of the storm surge model of IIT storm surge model, and this could predict up to 96 hours very accurately generation of the storm surges in the coastal area. So with this, I come to end of my presentation, because I don't know that it is short time for everything, but it is so that the AirDo model provides better track guidance, while intensity is more. S2R provides better track and intensity forecast, and the coupled model has a lot of scope for its improvement of track and intensity. And here, as I told, data assimilation plays a very important role, both ocean and atmospheric data assimilation. As Dr. Rajivan told, it's a coupled assimilation of ocean and atmosphere that will be very good in prediction of the cyclones, and also use of the assimilation of Doppler radars, satellites, radiance, and other things. So will substantially improve. And we hope that we can even further improve the prediction of the tropical cyclone and in this North Indian Ocean. Thank you very much.
Thank you very much, sir, for your excellent talk on various aspects of the cyclone modeling and forecasting. You have clearly brought out the important needs of the hour regarding data assimilation, quality of data, and also the modeling, especially the coupled modeling process involving the atmosphere and ocean, and also the land surface processes. So thank you very much. I think there is no question in the chat box. Because of lack of time, we can move to the next speaker. I requested Ravichandran to introduce the next speaker.
Thank you, Mohanty sir. Can you unshare your presentation, sir?
I'm unsharing. Where is the unshare?
So the next talk will be by Dr. Satish Chandra Shenoy, and he will be talking about the importance of Indian Ocean dynamics and thermodynamics for the Indian monsoon. Dr. Shenoy is a former director of Indian National Center for Ocean Information Services. He was also director of NIOT for some time. Dr. Shenoy significantly contributed both in terms of marine science research as well as the marine science management. He did his MSc and PhD in physical oceanography from School of Marine Sciences, Cochin University of Science and Technology. And he was a researcher in NIO since 1983 before he joined as a director of INCAIS in the year 2009. He has more than 30 years of research experience in physical oceanography. He played a pivotal role in many of the experimental programs such as Arabian Sea Monsoon Experiment by DST, which changed our traditional view from the passive role of ocean in monsoon process to an active role in the monsoon sea coupling. After tsunami 2004, he coordinated the research that described quantitatively the tsunami of the Indian coast and enabled an improved estimate of the extent of the tsunami source region. This work helped in improving the Tsunami Early Warning Center at INCAIS and leading the setup of ocean state forecast using various numerical models. He has also significantly contributed ocean observations and understanding the dynamics of the Indian Ocean. He was elected as a fellow of Indian Academy of Sciences. He has co-authored more than 100 research papers in journals of international repute. His professional interests include observational oceanography, ocean currents, impact of oceans on monsoons, and satellite oceanography. He is also involved in, he has spearheading a major setup he has done in establishing International Training Center for Operational Oceanography, ITCO Ocean of UNESCO Category 2 Center to promote training and capacity building for the Indian Ocean region in the field of operational oceanography. He is also a recipient of National Award in the Ocean Science and Technology by the Ministry of Earth Sciences, and also he is currently Vice Chairman of the Intergovernmental Oceanographic Commission. He was, of course, he was, you know, most of the people, you know that he was a long stint at INCAIS and he brought out more visibility of INCAIS and ocean services when he was at INCAIS. With this brief, now I request Dr. Shenoy to deliver his talk. Dr. Shenoy?
Yeah, thank you, Dr. Ravi. Can you see my picture?
Yes.
Okay.
Yes, you
yeah.
can make a full screen.
Yeah.
Nice. Yeah.
Let me first thank both societies, especially the president of India Meteorological Society, as well as Ocean Society, Dr. Mohapatra and Dr. Devi, for inviting me to deliver this talk on this WMO Day. I'm very glad that both societies have come together to celebrate WMO Day, as previous speakers as well as Secretary MOES had mentioned that we cannot separate ocean and atmosphere. They are together and they are complementing each other. So this is a good decision of both the societies, and I appreciate the decision of the presidents of both the societies to organize such symposium together. Let me also thank my senior colleagues and previous speakers, Dr. Shailesh Naik, Professor Mohanty, and other panelists, Dr. Krishnan, and other distinguished guests who are attending this seminar. So I was wondering what I should talk on today's symposium, and it is the WMO Day theme is related to ocean and atmosphere. So I thought I will put forward some of the issues which I came across during my research career, that how important is the ocean. As we know that the oceans are important, but my argument is that the oceans are not just playing a second fiddle for the monsoons. Oceans are also equally important, or they are also playing the same orchestra along with the monsoon to keep the onset to the progress of the monsoon. That is what I want to make a point in this talk today. Our traditional concept of monsoon, especially during the summer, northern summer, May to September, the continent is very warm, and that will lead to a giant low pressure over the continents. And the oceans are cooler, especially the southern part of the Indian Ocean is cooler, and we have this subtropical high, or what more popularly called Mascaran high. So there is a high pressure, high and low, and automatically it sets the winds to flow from high to low, and we get those winds over Southeast Asia, especially on over India, and we have the monsoons. There is no doubt that that is happening. But in this concept, the focus was on the Himalayas as a key influencer for the South Asian monsoon. It is it is known that Himalayas are it is thought that the massive mountain ridge acts as a barrier against cold winds blowing in from the north and insulating the Indian subcontinent in a warm cocoon and enhancing the summertime temperature difference between the land and the ocean. That is true. That is happening, but that is all driving this monsoon? That is the larger question we had to ask. People, in fact, earlier demonstrated this idea with some of the models, but by keeping the Himalayas and removing the Himalayas, and demonstrated that without Himalayas there won't be any monsoon. But those models, I'm talking about the models which are run in the quite a few decades ago, and those models didn't have ocean in that. So the Himalayas, when you keep or remove, you found a monsoon or not found a monsoon. That's true. But the point has to be noted is that these models didn't have ocean in them as such to see the changes. So if the land sea contrast is enough to sustain the monsoon over the season, it's a long season of about 4 months. So if that is enough, then the land sea contrast in surface temperature is small after monsoon onset, because we get the rain and the land temperature comes down. So what happens then? If land sea contrast is driving the monsoon, so we have a monsoon starting in June, lot of rains and the land's temperature comes down, but more vigorous rains are coming in July, August. So that's a question mark on that. And land sea contrast in surface temperature is large in regions with low rainfall. You know that some of the areas don't receive the rain and the very warm areas. But if the contrast is the one which is driving the monsoon, those areas should have much more rains, but that's not happening. Similarly, the land sea surface temperature contrast is small in good monsoon years. So if land sea temperature contrast is the major factor, then we shouldn't have had that kind of a good monsoon. So basically, there is no proven relationship between monsoon rainfall and land sea contrast. So this whole idea of the monsoon engine, which is driven by land sea temperature contrast, is a little, of course, that is required, but it is not the whole thing. So other ideas came in later, especially this intertropical convergence zone. That idea which put forward says that the intertropical convergence zone initially it lies over the southern Indian Ocean or south of the equator, and gradually that moves towards north, and when it comes over Southeast Asia and Indian region, we get the monsoon. That is following actually the warm pool which forms over the Indian Ocean. So in January, if you look at the warm pool is south of the equator, then gradually as the sun moves towards north with the more solar insolation received by the ocean, this warm pool also moves towards north, and the intertropical convergence zone also follows that evolution of the warm pole over the Indian Ocean, that also moves towards north. So by May, the entire region, North Indian Ocean region is becoming the most warmest or the warmest ocean in the world itself. So you can see that most of the warm pole is over the northern Indian Ocean, and it extends even over the western Pacific also. So this sets the ground for the monsoon. So your ITC set also moves along with that over the land, and it can give the rain. But the question is, if you look at that warm pole more carefully, you will see that the core of the warm pole lies somewhere of the southwest coast of India or in the southeastern Arabian Sea. You can see that blob I have marked there in the southeastern Arabian Sea, and that is the core which forms. And if you look at the that core, why that core is forming there, not along with the or the entire region where the ITC has formed. And if you look at examine the net heat flux, there are no evidences that because that region is getting more net heat flux, and that is what is causing this core to develop there. There are no evidences at all. That's what I am showing here. And if you look at the ocean, there are some indications. If you look at the ocean, there are some highs or the sea level high which forms in that region. In fact, if you look at this, each of the graphs carefully, or each of the pictures carefully, these pictures are from the satellite altimetry. From November to June, you can see that those high, it initially forms over the southeastern Arabian Sea or southwest coast of India, and they move towards west, spreading towards west. So a high means your thermocline is very deep, and you have a large, thick mixed layer there. And this high has been reported way back in 1994 by Bruce et al. That there is a sea level high forms in this region, and that stays there for some time. But later, when the altimeter came in picture, we could see that this high not only forms, it forms and expands towards west. So this is one ground which the ocean provides for this core of the warm pole to form there, but that is happening much before the ITCZ moves there. So what is happening is this high forms there sometime in November, December itself, much before the ITCZ moves over that region, and provides the necessary ground for the formation of the core of the warm pole. And when the high forms, the East India coastal current brings the fresh water from Bay of Bengal over that high and spreads that fresh water over the region. So there is a high, deeper thermocline, and over which the fresh water is spread over. So it is an ideal location when more solar insolation is put in there. There is no, it is a well stratified region there, no much mixing is happening, and that region can become more and more warm, and that is forming that core of the warm pole. So we have summarized this sequence. For example, and we also looked at what causes that high to form. Actually, what is happening is after the collapse of the previous monsoon in October, a downwelling Kelvin wave appears as an equatorward EICC, East India coastal current along the east coast of India, and that brings fresh water into this into the sea level high region in way back in November itself, and by January, the region of high sea level and low surface salinity forms in that Lakshadweep sea region, and the stable stratification and downwelling provide favorable conditions for surface warming, and increased solar radiation insolation leads to a blob of high SST by March. And that high SST probably, we have not done much research on that, because if you look at the rainfall pattern in Kerala, you will have early rainfall also, even much before the onset of the monsoon occurs in April itself. And we summarize that, or we feel that that warm pole which forms over the Lakshadweep Sea is the basic necessity for the formation of that April rainfall. And if you look at the monsoon vortex formation, whenever it forms, that also forms over that region. So there is a connection between the ocean and the entire formation of the monsoon, and this completely that warm pole over the Lakshadweep Sea, which leads later to the greater warm pole and acts as the core of the warm pole, that is completely formed because of the ocean dynamics and thermodynamics. That is the that's the point I want to make here. And if you look at this warm pole, as I showed earlier, by the May, the warm pole is filling the entire North Indian Ocean. But as soon as the monsoon onset occurs, early June or late May, the Arabian Sea starts cooling. As you can see that the Arabian Sea starts cooling, and the Bay of Bengal remains warm, supporting a lot of convective activity. So cooler Arabian Sea and warm Bay of Bengal sea surface temperature, it starts being that very different. And soon by July, August, you can see that the entire Arabian Sea, the SSTs fall below 28 degrees centigrade. It's a rough criteria to support the convective activity. And in the Bay of Bengal, that temperature still remains above 28 degrees centigrade. But if you look at the shortwave radiation or shortwave flux over these two regions, Bay of Bengal and Arabian Sea, you see that more shortwave is received by the Arabian Sea and than the Bay of Bengal. but in spite of that, the Arabian Sea cools. So what is the reason for that? Therefore, to examine that reason, we did a extensive calculation of the heat budget of the basins to find out why Bay of Bengal remains warm when the Arabian Sea cools down. So for that, we have done a extensive calculation of the heat budget. We have taken the surface heat fluxes, all the heat fluxes, short wave, long wave, and latent heat flux and sensible heat flux, and the coastal upwelling, which is happening on the western part of the Arabian Sea. That upwelling, how much it will cool down the Arabian Sea, and similarly the meridional overturning, and because of the meridional overturning, the heat can be transported towards the south, or it can be transported towards north through the southern boundary. So we defined an area of northern Indian Ocean, Bay of Bengal, as well as Arabian Sea, and did a calculation. And what we see is that you can see that if you look at the fluxes, they are not very different. They are the net air sea fluxes, what the Arabian Sea and Bay of Bengal receive are similar. So that cannot be the cause for a warmer Bay of Bengal. But the issue is coming from the ocean side, that is the meridional. If you look at this blue curve and the coastal, that the green curve, that is creating this difference. That means you are removing much more heat, greater amount of heat towards south from the Arabian Sea, and than the Bay of Bengal, that's on the right side here. And similarly, the coastal overturning, or due to the coastal upwelling in the Arabian Sea, much more heat is removed compared to the very weak coastal upwelling in the Bay of Bengal, that is not removing much heat. So this heat budget, very difficult to get closer of the heat budgets usually, but by doing the very careful calculation and defining each of those terms very carefully, we could get a closer of the heat budget also. So there is no doubt that this is what is how the heat budget is behaving. So only because of this difference in meridional overturning or meridional removal of the heat from the Arabian Sea towards through the southern boundary, and the coastal overturning, or due to the coastal upwelling along the west coast of on the western side of the Arabian Sea cools down. And in the absence of both of that, or very weak factors in the Bay of Bengal, the Bay of Bengal remains warm, supporting the monsoonal activities. And added to that, we have greater wind stress, or heavier winds over the Arabian Sea compared to the Bay of Bengal. And because of these reasons, the warmer Bay of Bengal, greater the convective activity and the greater precipitation, and the Arabian Sea receives a lesser amount of precipitation. So what happens is, because of this, the Bay of Bengal waters becomes more stratified, because you receive more fresh water on the surface, and the Arabian Sea water becomes more homogenized. So you have greater winds over the Arabian Sea, lesser precipitation, and more homogenized water, because the mixing is happening much vigorously over the Arabian Sea, and that is happening much lesser scale over the Bay of Bengal. You can do a back of the envelope calculation to see how much energy is required to mix the Arabian Sea, because we know the temperature, salinity structure, or the density structure. We can easily calculate what is the energy required to mix the Arabian Sea upper mix layer, and or upper 50-meter water column, and what is the available turbulent kinetic energy in Arabian Sea and Bay of Bengal. And if you do this back of the envelope calculation, it takes about 4 days for the Arabian Sea to mix the upper layer and cool down, whereas Bay of Bengal needs 60 days for such a in that situation to mix and mix the waters leading to the cooling. So these are not the exact numbers. This is just a rough calculation to give an idea that how much time difference or how many days are required to mix the waters in the Bay of Bengal and Arabian Sea. So if I summarize whatever the factors which are affecting, you can see over the Arabian Sea, there are strong winds, especially that Finlater jetties over the Arabian Sea. And because of the strong winds, we'll have a strong vertical transport, vertical or the mixing. And because of that, the SST will cool down, and cooler SST will lead to weak convective activity. Weak convective activity will lead to a negative P minus E or less precipitation over the evaporation, and negative P minus E will lead to weak near surface stratification. So the water is not very much stratified. And if you look at the Bay of Bengal, the winds are comparatively weaker over the Bay of Bengal compared to the Arabian Sea, and weak vertical transport because the mixing is very weak. And that leads to warmer SST because mixing is not taking place vigorously like Arabian Sea. And warm SST supports strong convective activity, and the strong convective activity leads to more precipitation. So P minus E over Bay of Bengal is positive, and that leads to strong near, because more fresh water is received from the precipitation as well as from the rivers around the along the Bay of Bengal. So it leads to strong near surface stratification. So you can see that Arabian Sea, both are sort of a positive feedback cycles, but Arabian Sea, the cycle is operating in one direction, and over the Bay of Bengal, the cycle is operating in the opposite direction. But both are feedback mechanisms, and they are working, sustaining the conditions what is over Bay of Bengal and Arabian Sea. So because of that, if you look at the, of course, I could not get a updated number of low pressure systems over Bay of Bengal and Arabian Sea, because we know that these low pressure systems which forms over the Bay of Bengal, they are the ones which are bringing a lot of rains for the central India as well as the western, northwestern part of India, or most of the parts of India except the west coast. So these depressions or low pressure systems, they form over if or the Arabian Sea, very few, less than 10 numbers or tens of low pressure systems forms over Arabian Sea. The hundreds of low pressure systems forms over the Bay of Bengal, or more number of these kind of depressions and low pressure systems forms over the Bay of Bengal, only because the Bay of Bengal remains warm. So if we create similar conditions for Arabian Sea, or cut off the freshwater supply to the Bay of Bengal, we may destroy our monsoon itself, because the Bay of Bengal may not remain as warm as it is today. But in the recent years, if we look, more depressions and cyclones are forming over Arabian Sea also. Of course, this is a very interesting research topic. I have not researched much, and if I get an opportunity, I would look at that more carefully, what changes are happening in Arabian Sea, which is supporting this, supporting the formation of more depressions and more cyclones in the recent years, which we say that they are part of the climate change. We don't know exactly what is happening in the ocean, or what dynamics of ocean is supporting these issues. So this hypothesis has led to the concentrating on Bay of Bengal and the importance of salinity and advection in the Bay of Bengal, because that salinity and advection are the two key factors which keeps the Bay of Bengal warmer and supports the monsoonal activity. So that keeping the Bay of Bengal warmer and conducive for convective activity that keeps the monsoon active over most of India. And two large-scale experiments were conducted, supported by MOES. One was 3 OMM ocean monsoon mixing together with the US collaborators, and another one with UK collaborators called Bobley. And both these gave a lot of important information on how the mixing and what is mixing is happening over the Bay of Bengal, and how the freshwater or the salinity is important in controlling this mixing, and the finer scales of turbulence and mixing has come. And more experiments are still going on in the Bay of Bengal. In a recent paper published in Journal of Climate in 2019, that also came out with the ocean activity or the southward transport of heat, what we also found from the heat budget calculations, is the key controller of summer monsoons. What they say is the southward transport of heat cools the sea surface temperature south of India and increases the reverse meridional surface gradient of moist static energy, shifting the precipitation maximum over the land and strengthening the monsoonal circulation in the sense of enhancing the vertical wind shear. So this paper also clearly brings out the importance of ocean dynamics in controlling the monsoon activity and supporting the monsoon. I think these are very important issues which has to be taken note of to improve our prediction of the monsoon. The other factors, I am not going to go very in detail about them, because we know that Southern Ocean oscillation, they are other oceanic factors which influence the monsoon, as well as the dipole mode in the Indian Ocean. That also is very crucial for the prediction of the monsoon, which shows that if the dipole reverses, then there is a change in the behavior, and also the Atlantic multidecadal oscillation. So these are all oceanic modes. There's El Nino as well as the dipole, Indian Ocean dipole, and the Atlantic multidecadal oscillation. These are all oceanic modes which are very influential and determines the monsoonal activity over the Southeast Asia, as well as especially over India, which is of greater interest to us. And also the equino, though, which is said to be the atmospheric part of dipole. But I feel that more and more evidence is coming out from a series of papers wrote by Professor Gadgil and her co-authors, that especially the recent monsoons, why most of the models have gone wrong in predicting the recent monsoons. Either when they predict normal monsoon, we had recently excess monsoon. Similarly, the models which predicted above normal monsoon, we had a deficit monsoon, etc., etc. One key factor which is going wrong in these models is that these models, though they are able to capture the El Nino and other factors right, they are unable to capture the equino and its relationship with the rainfall over India. So I think we had to put more stress on understanding this equino or the convection over the western region and its relationship with the rainfall, to come out with to address these kind of issues. So an important step in understanding the evolution of equino is identifying the factors that determine the convection, and how that convection finally converts as rainfall over India. The lead candidate is, of course, the SST. But what about the oceanic processes that determines and sustains SST over a season? Can we predict the evolution of SST very clearly from knowing the oceanic dynamics and oceanic features? I think we had to make many more observations to determine what exactly is controlling this. So let me conclude that we have to understand how the ocean is responding and influencing for accurate prediction of the monsoon. And one cannot just focus on land and the atmosphere. The ocean is the key for the accurate prediction of the monsoons. Thank you very much.
Thank you. Thank you. Articulated about the importance of the ocean in modulating the monsoon. Start from the conventional things and the local forcing and a lot of climate modes and some food for thoughts. Especially, we have to put more stress on understanding the equino and its importance. Thank you very much. And due to want of time, maybe I can. There are many questions. Maybe we can take it up a little later.
Sure.
Thank
Sure.
you. Thank you. Thank you.
Thank you, Ray. Thank you.
Thank you.
Thank you, Dr. Sinasa, for your excellent presentation. And you have brought out the importance of various types of observations required to understand ocean atmosphere interactions and its application in numerical modeling. And this understanding also helped provide the forecast with respect to one set and other features of monsoon, and also the understanding of the genesis of monsoonal disturbances. So thank you very much. We'll go to the last talk of this evening, and I am happy to inform that Dr. Krishnan is currently the Executive Director of Center for Climate Change Research in Indian Institute of Tropical Meteorology, Pune. He is well known in the world, basically because of his contribution towards the climate change research. Especially if we all remember, he and his team contributed immensely for development of Earth system modeling in Ministry of Earth Sciences. And we have given, under his leadership, the first global climate model-based scenarios for the CMIP 6 and IPCC 6th assessment report. He and his team has put out a statement, you can say, with respect to the national climate in the country. Climate change assessment report has been published by Minister of Earth Sciences with his leadership and contribution. He started his career after his PhD, and then he has served in many organizations. He worked in Physical Research Laboratory, Ahmedabad, the National Center for Meteorological Weather Forecasting, Delhi, Indian Institute of Tropical Meteorology, currently where he is now. He has served as acting director for some time in IITM Pune, and currently he is continuing as executive director of Center for Climate Change Research. He has many assignments abroad, and he has also been recognized with many honors and recognitions. I'll just mention a few. He has been Fellow of Indian Academy of Sciences, Indian National Science Academy, and Indian Meteorological Society. He has been the member of Joint Scientific Committee for World Climate Research Program. He has been the coordinating lead author for the 6th assessment report of IPCC Working Group 1. He has done a very pioneering work in the frontier science of climate change research. He has received the Frontier Outstanding Research Award for SGC, Japan, twice. He has received Golden Jubilee Award and Silver Jubilee Award from Indian Institute of Tropical Meteorology, Professor Anandu Varnekar Award from Indian Meteorological Society, and he has been the member of the monsoon panel in Clivar of WCRP WMO. He has been a member of the Codex Science Advisory Team, a member of the Scientific Steering Committee for Monsoon Asia Integrated Regional Society. He has been authoring many books and also editing the journals. He has been associate editor or editor either special issue or the normal issue of many journals. So he is also guiding a number of students for PhDs, and many have benefited from his knowledge, experience, and expertise in this field. I am happy to invite Dr. R. Krishnan to deliver this lecture. Thank you, Krishnan sir.
Yeah. Thank you, Dr. Mahapatra Saab, for this nice introduction. And also, I want to thank Dr. Ravichandran and Dr. Mahapatra and Patnaik for inviting me to give this WMO Day lecture, organized jointly by the IMS and OSI. I think it's a very, very important initiative. Very nice to know about that. And I also want to thank all my previous speakers, Dr. Sailesh Nayak, Professor Mohanty, and Dr. Satish Anai, who have really set the stage for my talk. And today's talk will be on the role of oceans on future changes in the regional monsoons. Can you see the slide, please? Hello? Yeah.
Yes, sir.
Okay. Thank you. Thank you very much. So basically, I'll be starting from some of the concepts that Dr. Shanai has introduced in the previous talk. This is a very conceptual picture of the South Asian monsoon. Is already set the stage. So you need a land-sea contrast. It is necessary but not sufficient to set up the monsoon to begin with. So when the winds develop in response to the pressure gradient and the thermal gradient, it picks up a lot of moisture from the ocean, Indian Ocean, the Arabian Sea. And this leads to buildup of the moist static energy over the Indian region. And many studies have shown that the maximum moist static energy, which is located over India, that is the region where all the convection develops. And so you need a thermal contrast to begin with. But once it is established, there is a feedback between the latent heat released by the convection, by the clouds. And this latent heat is substantial. I'll be showing in my next slide to drive the continental scale circulation. And so this feedback between the circulation and latent heat maintains the monsoon throughout for 4 to 5 months. And so this is a very simple schematic. Of course, there are year-to-year variations in the rainfall that are influenced by internal dynamics within the monsoon system and also external drivers. So this is a old schematic from Professor Krishnamurthy and Balme in 1976. The coupling between the circulation and the rainfall or the latent heating, the cloud is very clearly demonstrated. So it is a convectively coupled system where the convection couples the winds both in the lower level and the upper level through this organized convection, which extends over all the way from the Indian region into Southeast Asia and into the West Pacific warm pool. It's really convection is organizing over a very large scale. And now we have the TRIM satellite data. We can estimate the vertical profile of latent heating because the precipitation radar gives the vertical hydrometeor structure. And this is a structure of latent heating climatology from the TRIM product. You can see the heating can be as large as 5 to 6. This is just the climatological mean over the Bay of Bengal, also over the west coast of India and the central and north India. And when we look at the latitude height section, you can see the maximum heating is somewhere in the middle and upper troposphere. And so convection is very, very dominant. And this convection can really drive the circulation on a continental scale. So in the upper level, just in the upper troposphere, you have strong easterlies, you have a Tibetan anticyclone, you have the easterly jet, and you have a low-level monsoon westerly jet. So this is a large-scale overturning circulation, the monsoon. It is linked to the organized convection. That is the important point. And now what we are seeing is the global mean temperatures have risen. So climate change is a reality. We are already seeing this. The planet has warmed by about 1 degree. And the question is, what will happen to the monsoon? And so this it has been documented by various studies that this increase, rapid rise in temperature, which we have seen in the last few decades, is attributable to the increasing concentration of greenhouse gases, especially carbon dioxide, which is a long-lived gas. And now this has 2020, the value had reached 415 parts per million from the pre-industrial time of about 280. So this is a very substantial increase. And so the trapping of the energy, long wave radiation, terrestrial energy by these greenhouse gases and its downwelling back the long wave radiation has warmed the planet. So the question is, how is climate change, how is this warm, how is it going to affect the monsoon in the future, and what it has done in the past? So this is from the AR5 assessment. This is from the multi-model assessment for different scenarios. The low emission scenario is RCP 2.6 and goes to the RCP 8.5, which is a very high emission scenario. You can see with increasing temperature, the upper panel is for the temperature change over South Asia. The lower panel is for the precipitation change. So with increased warming, we can see with the high emission scenarios, the increasing temperatures, that is very clear. But we see also a lot of spread across the models. And this is a big concern, and this is more so for the precipitation change. So the precipitation change, there is an projected increase in precipitation, but highly uncertain because of the large spread across the models. This situation also continues with the AR6. And this is with the CMIP6 model for the historical period. When we look at from 1951 to 2014, there has been a slight decrease in the precipitation over South Asia and Southeast Asia. And we have done several attribution studies, detection attribution studies. And part of this decrease, to some extent, it is explained because of the increasing anthropogenic aerosols in the northern hemisphere, which have kind of offset the expected increase in precipitation due to GHG increase. But that again comes with a lot of spread. And once we go into the future, I'm just showing it for two scenarios: the moderate scenario SSP 245 and the SSP 585 is a kind of high emission scenario. So there is precipitation is projected to increase, but still with a lot of spread across the models. So this is a big source of uncertainty. So how do we deal with it? So that is point number one. So in the AR5, it is not just over South Asia. When this is an assessment of precipitation changes over the entire global land monsoon region. So we can see that with increasing under the different scenarios, this is of course with the AR5, precipitation is projected to increase under warming and as well as evaporation. And moisture convergence is projected to increase overall over this entire global land monsoon region. But the interesting point is the convergence of the wind itself. The models project that convergence will decrease and the winds will slow down. Basically, the water vapor is increasing in the atmosphere, leading to stronger convergence, although the winds tend to slow down. This is what all the, and I will come to this. So we have to keep in mind the circulation is kind of weakening, projected to weaken, whereas the moisture is increasing in the atmosphere. So it's more of a thermodynamical response to global warming. And this is a very simplified illustration of this effect of climate change on the monsoon. So basically, when you have a seasonal variation in the solar insolation, the solar radiation, so the land warms up and you have the moisture from the ocean flowing into the land region, and this sets up the monsoon circulation. So in the future, as this warming land gets warmer faster because of the lower heat capacity, the land-sea contrast is projected to increase. And so there is much more evaporation because of the Clausius-Clapeyron equation. So the thermodynamical response to increase in the temperature, for every 1 degree rise in temperature, water vapor in the atmosphere increases by 6 to 10%. And so once you have increased moisture in the atmosphere, which is going to be transported by the winds, so there is more moisture convergence and more precipitation. However, all the models, what they show is the moisture increases at a much faster rate per degree warming compared to the precipitation rate of precipitation. And using the thermodynamic argument, what it suggests is if moisture is increasing at a much faster rate and it is not raining out, the circulation has to weaken. And this is the concept that people have been pushing. And of course, this has the potential to increase heavy rainfall over the region because of availability of more moisture. And the physics behind the weakening of the circulation, but more precipitation is as follows. Basically, the precipitation is related to the vertical velocity, the convergence of the water vapor. So you have the upward velocity, it's a product of the upward velocity and humidity. So when you look at the change in precipitation and change in humidity, the water vapor, and change in the vertical velocity, this is by Held and Soden. So generally we find that water vapor increases by about 7% per degree warming, whereas precipitation or evaporation increases at a much slower rate, about 1 to 2% per Kelvin. So with this argument, what one would expect is the upward motions, the convection would decrease, the mass flux would decrease by 5% per Kelvin. So this is the argument that has been proposed by Held and Soden and various other colleagues. And but now when we go to different regions, not just over South Asia, other regions, other monsoon regions of the world, like West Africa, for instance, South America, or the Australian, Indonesian maritime continent, the drivers of monsoon variability are not same. You can have different forcing mechanisms. So we have to understand that it's not just the greenhouse gases, there are other drivers. And also there are different time scales. And so there is a substantial regional character to these monsoons. And and this is possible. This was a study based on paleoclimatic evidence where they looked at monsoon variations in the past several thousands of years. And they come out with the idea that it has a substantial regional character and the drivers are very different. The monsoon dynamics is very different from region to region. So, and in fact, building on these lines, we had done a study over the Indian region during the historical period, as I said, when the temperatures have in fact increased substantially from the 1950s globally and also over the Indian region, precipitation actually declined. And this has a lot of intra-annual and decadal variability. But despite that, we see that there's been an overall decrease in rain over many parts of South Asia, something about 6 to 7%. So how can we understand this? So what we found in this study was while the greenhouse gases are trying to enhance the precipitation over India, there are other factors like the aerosols in the northern hemisphere, as well as land use, land cover changes, which have kind of offset the expected precipitation enhancement. So there are various drivers we have to keep in mind. So basically there is a tug of war on rainfall changes coming from different forcing elements. And this was based on very high resolution experiments. What we showed was this is the historical natural experiment where there are no changes in the anthropogenic forcing during the historical period. And this is a very high resolution model. It captures the heavy precipitation over the Western Ghats and also the heavy rainfall over the Bay of Bengal. And the circulation is very tightly linked to the precipitation. Interestingly, what we found compared to many CMIP models for the historical period, that is 50 to 2005, the precipitation difference between the historical and the natural actually showed a decrease in the precipitation. This is the change, and the circulation weakened. So this is contrary to what we see in other models, other CMIP models. Whereas if we have only greenhouse gases, both the rainfall increased over India and also the circulation intensified. So this is an exception among many CMIP models which show that the circulation will weaken. So in this particular experiment, it's not only the precipitation increase, but also the circulation intensifies when we have only greenhouse gases. But when you have other effects like the aerosols and the land use changes, so the drivers can offset the effect of the GHG forcing. So we have to really understand whether the circulation is going to weaken in future. That is point number one. So that is the title I have given. So the other topic I'll be talking is related to the ocean. What happens to the ocean SST gradients? So we need to, I will not, there are a whole range of uncertainties, but I will just focus on two aspects. How do we understand this weakening circulation. That is an uncertainty because circulation and precipitation are coupled. The other thing is what happens to the large scale SST gradients in the ocean. This will be the focus. With regard to the precipitation itself, as in the last slide which Dr. Shenoy presented, there has been attempts in recent times to understand the monsoon precipitation dynamics in terms of the ITCZ dynamics. And this is a surface well-known position of the ITCZ during January and July. This is from Professor Hasnani. So you can see the organized, the ITCZ aligned to the south of the equator during July and during January, and it migrates to the north in the boreal summer. And so now several people have looked at understanding precipitation dynamics based on the ITCZ. The idea is the zonal mean ITCZ is located north of the equator. This is on an annual mean. So if you take the annual mean precipitation, the ITCZ is located to the north of the equator at around 6 degrees north, which means that the ITCZ is co-located with the ascending branch of the Hadley cell, is located slightly to the north of the equator. And this ascending branch of the Hadley cell, basically it exports energy in the upper branches of the Hadley cell. This is something like 0.2 petawatts. From the upper branches, there is transport of energy, the moist static energy, which converges into the monsoon regions. And basically the atmosphere fluxes out the energy out of the hemisphere where the ITCZ is located. And ITCZ stays in the warmer hemisphere. This is something very important. I will also show in my next slide, where the atmosphere is heated from below. So the ITCZ always stays in the north of the equator. This is from a zonal mean perspective. And the Hadley cell basically transports the energy to the other hemisphere. And now there was another interesting paper by Schneider et al. In Nature on the migration and dynamics of the ITCZ. So they argue that the mean position of the ITCZ to the north of the equator, it arises because of the Atlantic Ocean. It transports heat energy in the ocean northward across the equator, rendering the northern hemisphere warmer than the southern hemisphere. So what they argue is this is the position of what they have shown in this picture is the annual mean rainfall and the fluxes of moist static energy vectors. And you have the divergence shown by the contours. So in the subtropical regions, you can see there is higher divergence of the moist static energy fluxes. Close to the equator, it is positive, but not. It is small but positive. And basically, the transport of the energy by these moist static energy is what maintains the position of the annual mean Hadley cell. So the Hadley cell basically transports energy away from the ITCZ region. And in the low level, you have the easterly winds in both the hemisphere. And there's an interesting ocean atmosphere coupling that takes place close to the equator. This they have projected in the Atlantic Ocean, where you have trade winds coming from both the hemispheres. And these easterly trade winds then transport they drive subtropical cells in the oceans, and these cells further transport heat in the ocean away from the equator. And there is convergence of close to the equator, there is upwelling which brings the cold water. So this is a coupled system. So basically the maintenance of the ITCZ to the north of the equator is also related to the heat transports taking place not just in the atmosphere but also in the ocean. And building on this, there was another paper in 2018 by Biasuti et al. So they say that the global constraints of momentum and energy govern the variability of rainfall belt in the ITCZ and the structure of zonal mean tropical circulation. But however, when you go to continental scale monsoons, even though the facets of momentum and energy constrain global circulation, they are dependent on that. But when you look at the observations and also the paleoclimate data, it really substantially deviates from that of the ITCZ. So what they argue is this is an example from the TRIM data. This is for July 2015. You can see the large scale structure of the ITCZ where rainfall is organized. And this red contour is the region where you have a 45 millimeter of column integrated water vapor. It's very high water vapor, very moist environment where all the organized convection is taking place. But when you start looking at the details of the rainfall within each of these monsoon regions, they're different from what is really happening in the ITCZ. So if you take the climate, the zonal mean of the rainfall along the ITCZ and an instantaneous picture, very, very different, implying that the regional monsoons are much more different compared to the what we see, the ITCZ dynamics, and which we need to understand, and a lot of work is needed. And building on the same point, now when we come to the South Asian monsoon, this was a paper by Sabir Ali et al., who analyzed the CMIP models and the precipitation over South Asian monsoon region. And as I said earlier, the TRIM data now, we are able to separate how much is the convective rainfall and how much is the stratiform type of rain, very organized rainfall, which is seen during the summer monsoon season. So the TRIM observations show that typically the ratio of convective and stratiform during the June to September over the South Asian region is 50% each. However, many of these models, CMIP models, both for the historical period and the future projections, they predict excessive convective rainfall and they underestimate the stratiform rain. So the problem is this improper representation of the convective process leads to problems in the temperature profile, the temperature distribution in the vertical, and this also affects the stability of the circulation, and it can affect the circulation response to the monsoon. So this is one of the things that we need to address, how to improve the convection. That is problem one. The other thing is linked to the ocean, because as I said, and we have also these drivers both on intraannual and decadal time scale, the ENSO, the IOD, and the Pacific Decadal Oscillation. So they are going to modulate the changes in the monsoon, variations in the monsoon. So this is the schematic which I picked from the IPCC AR5. What are the likely changes in the Walker circulation under climate change? Basically, the Walker circulation is and the El Nino and Southern Oscillation and the Walker circulation and the trade winds and the Pacific SST gradients, they're all closely coupled to one another. It's a very strong coupling, ocean atmosphere coupling known as the Bjerknes feedback. So in the Pacific, you have the West Pacific warm pool and you have in the Eastern Pacific cold SST because of the upwelling. And there are strong trade winds. So the SST gradient is more than 5 to 6 degree difference is there. And so the convergence of these easterly winds, which bring moisture into this region, it maintains the convection over the West Pacific warm pool. And this coupled interaction drives this large scale Walker circulation, east-west circulation in the atmosphere due to the heating in this region. And it also affects the ocean currents. And because in this, due to the ocean response, dynamical response to the easterly winds, you have the thermocline is shoaled upwards, and you have cold water upwelling in the Eastern Pacific. So now during El Nino conditions, when the trade winds weaken, the SST gradient also weakens and the ocean heat content moves eastward. Along with that, the rainfall and the convection also shifts eastward to the central and the Eastern Pacific. And due to this, during this time, the upwelling is reduced in the Eastern Equatorial Pacific, and you get a warm SST anomalies, which can be 4 to 5 degrees above normal. And this is a typical El Nino response where the SST gradient weakens. So in normal condition, we have a strong SST gradient, west to east positive SST gradient. Whereas during a El Nino condition, the SST gradient will weaken and the trade wind will weaken and the Walker circulation is weakened. Now, what the climate change and simulations, what are they indicating? So climate simulations, they are indicating that with the same argument that water vapor will increase at a very fast rate, but the precipitation increases at a slower rate. So what all these studies show is the static stability in the atmosphere will increase. And therefore, the tropical circulation and the Walker circulation will weaken. You can see this is the projection show that the easterly trades will weaken and the Walker circulation will weaken. And you will get a El Nino-like response. It is not an El Nino response, but you will get an El Nino-like SST pattern where the SST gradients are weakened. Now, this is what is suggested by all the models. large-scale SST gradients. And so this is by Vecchi and Soden. So in a globally warming environment, the tropical circulation will weaken. The upward motions in the West Pacific or the monsoon region is expected to weaken because the Walker circulation will weaken. Now, there is a very recent paper by Mark Kane's group, Seeger, Mark Kane et al. In Nature Climate Change. They have provided a counter argument. They suggest that the tropical SST gradient has actually strengthened during this period when greenhouse gases have actually risen. So they use observations and more simplified models. Their argument is the state of the climate models predict that rising GHGs reduce the west to east warm to cool sea surface temperature gradient across the equatorial Pacific. In nature, however, the gradient has strengthened in recent decades as GHG concentrations have risen sharply. This stark discrepancy between models and observations have troubled the climate research community for 2 decades. And they have analyzed this problem with more simplified models, and they show that the climate models are having problems. And they say that we use the same dynamics to show that the erroneous warming in the state of climate models is a consequence of cold bias in the equatorial cold tongue. So they use the observations from 1958 to 2017. They show, in fact, the SST gradient, large-scale SST gradient has actually strengthened, and the trade winds have strengthened. And in fact, on the other hand, the climate models, they seem to exaggerate. They have large problems in the cold bias in the equatorial tongue, and they project warming and the weakening of the SST gradient and trade wind. So this is one of the issues that has come out, which we need to understand. And also I will draw attention to a related paper on recent global warming hiatus to equatorial Pacific surface cooling. This was by Kosaka and Z in Nature. After the 1997 major El Nino, there was 1998, mid-1998, there was a La Nina. And that cold phase of the La Nina, it extended very much until 2012 or so. It was a very extended cold phase, and now in the literature it is known as it's a cold phase of a decadal oscillation. It's a decadal timescale mode. And what is actually during this period, the global mean temperature also did not increase much. And so in the literature it is referred to as a hiatus in the global warming. What the study showed is and during the hiatus period, in the global warming, the Walker circulation was actually intensified. The east-west Pacific gradient was stronger, the Walker circulation was intensified, and there were prolonged droughts over southern USA. And this result, they used a modeling experiment where they specify the SST forcing in the model over the Pacific, and other places they couple it for the historical period. And what they show is the hiatus results because of the natural climate variability, and it is specifically tied to a La Nina like decadal cooling. So this is what is their argument. However, they also mentioned that although decadal hiatus events may occur in future, the multi-decadal warming trend is likely to continue. The multi-decadal trend will continue in the future also with greenhouse gas increase. So this is something we need to understand. So on decadal timescales, there are these SSTs in the Pacific over a large areas can be warm or cold associated with, it's also known in the literature as the Pacific decadal oscillation. And this was an earlier study which we had done. The Pacific decadal, this has resemblance to the ENSO, but ENSO, the SST anomalies are mostly confined close to the equator. But when you look at the decadal timescale oscillation, it's more like a triangular pattern extending into the subtropics and the mid-latitude regions of the west coast of South and North America. And you have pronounced cooling in the extratropics of the Pacific, North and South Pacific. So this decadal timescale pattern also influences the precipitation over India, and it has teleconnections over the Indian Ocean. So normally the warm phases of the PDO are associated with warming in the Indian Ocean, and they are also associated with deficit rainfall, whereas cooler phases of the PDO can lead to favorable rainfall. And within these decadal phases, you can have intraannual El Nino and La Nina events, and they can also in turn affect the monsoon. So the big question is, this is one of the biggest source of uncertainty. What will happen to the PDO in the coming decades, and what will be its influence on the monsoon? And so this is something which we need to understand. The other driver is the Indian Ocean Dipole. This was a very important discovery that came in 1999 by Saji et al., which showed that just like what we have in the ENSO in the Pacific Ocean, also in the Indian Ocean, you have an important coupled mode of variability. And these positive IOD events, which had major ones in 1994, 1961, the wettest monsoon, and more recently during 2019. And you have this cold easterly trade winds, which produce a lot of upwelling in the eastern Indian Ocean. And you have also easterly trades along the equatorial Indian Ocean. And there is convergence in the western equatorial Indian Ocean, more downwelling and SST warming. And this east-west, this dipole can also drive water vapor transport because of the strong trade winds and the southeasterly trades. There is also a lot of evaporation taking place. And these moisture fluxes which evaporate, this we had shown in an earlier paper, that because of this, so as the IOD evolves through the monsoon season, rainfall may be deficit because of the cold SSTs and the upwelling. But there is divergence taking place in this region. So the divergence of the water vapor, so these water vapor fluxes which diverge out from the southeastern Indian Ocean, they can be transported into the monsoon region over the Indian subcontinent and Southeast Asia, and they can maintain this anomalous rainfall. So they can produce very strong precipitation enhancement. So the IODs can favor strong monsoons. And in fact, when we look
can
at
you conclude?
Yeah. So this is my last two slides. So when we look at the rainfall, you have multi-decadal variations, and in the last 2 years, there has been an increase in the rainfall from the declining trend. 2019 was more of a very strong IOD, and the 2020 was a La Nina year. And this was a recent paper by Satyaban Ratna from IMD, where they argue that the extreme positive IOD during 2019 played an important role in the rainfall enhancement during the 2019 monsoon season. So this is something which we need to keep in mind. So in summary, I want to highlight that large-scale SST gradients in the tropical ocean SST gradients, they are fundamental in regulating the tropical and regional monsoon precipitation, not just the mean, also the variability and extremes. So they do so by altering the heat and moisture sources and also the convective activity and large-scale circulation. So it's very important that the realism of the large-scale ocean atmosphere coupled model interactions in climate models is a key for improving the future projections of regional monsoons under changing climate. So this includes improving the representation of the ENSO, IOD, and PDO. And this means that we need a multi-pronged approach. Already there's good work that is going on, both in terms of basic research and operational services. But this we need to strengthen the basic research to back up the operational services. We have to develop a framework based on global energy constraint and regional monsoons, keeping the complexities of the regional dynamics. And this is important for reducing the uncertainties in the projections. So we will have to improve our process understanding, also the predictive understanding. This will involve combining observations and models for advancing predictive understanding of the ocean atmosphere coupled interaction on different scales. Already the ocean observing systems, the moorings in the Pacific, the Indian Ocean, the Atlantic, as well as the RO and the satellite observations have provided a lot of benefits in improving our predictive capabilities. And this we need to enhance. And also side by side, we have to improve the representation of physical processes in the climate models, mostly the organization of clouds, the stratiform and convective precipitation, the latent heating structure, the warm rain process, orographic precipitation, aerosol cloud interaction, and also the low-level clouds over the high-pressure regions in the Eastern Pacific and subtropical Indian Ocean. So these are some of my thoughts, and thank you very much for your kind attention.
Thank you, Dr. Krishnan. I think Dr. Mahapatra has gone to some other meeting.
Okay.
Yes, sir.
First of all, thank you very much for your nice, wonderful talk. I think you have summarized what are the various climate modes and how the tropical connections are happening and where the need for improvement and what are the process studies and observational requirement to improve the climate models. You have nicely explained. Thank you. Thank you very much.
Thank you, Dr. Ravi. Yeah.
I think this ends this fourth presentation, but now just maybe little bit of concluding things. I would like to point out some of the major outcome of the talk. So first one, I think Dr. Sailesh Naik nicely narrated the importance of blue economy, starting from, he started with the blue chakra, why it is that blue chakra and its blue revolutions meaning, and what are the opportunities and issues in various domains of ocean, like fisheries, coastal, mineral resources, energy resources, also hazard, oceanic related hazards, and how we have to empower for that. And also he has highlighted the UNCLOS issues, including EZ surveys and continental self-climbing of India. Then he touched about the coastal tracer minerals and deep sea minerals, TMN, hydrothermal sulfides, and cobalt crust. Then energy sources in terms of from the ocean, like gas hydrates, as I understand, reported 10% of the energy is more than sufficient for 100 years. It is really first time I'm hearing this. It is a huge reserve, but we need a technology. And also there are renewable energy from the ocean, like wind, wave, currents, thermal gradients, salinity gradients, biofuel, all these energy resources are available. And we need a technology for harness all these things, not only from the coastal, but also deep sea, and also fresh water from the sea. Then the service related activities like fisheries, pelagic fisheries, PFZ, and deep sea fisheries, and marine biotechnology also he has highlighted, and some of the coastal marine spatial planning of different teams and the ocean forecast services and many other related services also highlighted. And lastly, he has emphasized the importance of coastal tourism and other aspects. I think this is a very valuable information, a lot more things to do. I wonder how our institutions, I don't know whether our present institutions of ocean, all they will be able to take care of all these aspects. Whether I think we need a considerable amount of resources in terms of manpower and money is required. But ideally, it has come now under Deep Ocean Mission as well as the Blue Ocean Blue Economy project. I think we will be able to harness the ocean in a sustainable way. Thank you, sir, for your overarching what is called the importance of blue economy. And then later on, of course, Dr. Mogandi Saab has highlighted the advances in the prediction of tropical cyclones. Once upon a time, it was not predicted well, but now not only from the what is called this prediction has been tremendously improved from the point of view of the track, intensity, as well as the genesis. And he has also demonstrated the importance of coupling between the ocean and atmospheric model, and it has tremendously increased and the prediction. And as I understand, in the global warming scenario, maybe the many oceans are the intensity of the cyclones are increasing, maybe the number may be decreasing. So I think we have to concentrate on how we have to equip or how do we monitor and predict in such intensified cyclones and other things we have to make it. I think the only way forward is the ocean atmosphere coupling process or modeling, and maybe the initialization and assimilation of the many observations, not only from the ocean, but also in the atmosphere. I think it is a need, we need to have some of the aircraft of observations to initialize better vortex and other things. That is also very important. And the third one is Dr. Shenoy has emphasized the importance of the ocean in modulating the monsoon. And he started with what is called land sea contrast initial process and how ITC is playing. But now he has throw some light on how the whirlpool of the Arabian Sea is playing a major role, and what is its causative mechanism of this whirlpool by both atmosphere as well as the ocean governance. And also you mentioned about the way Arabian Sea cools more than the Bay of Bengal, and it is not mainly because of though both receive same amount of energy from the atmosphere, but Arabian Sea cools, whereas the Bay of Bengal remains warm, and the importance is the ocean circulation, especially the meridional circulations. He has nicely brought out that the importance of the ocean circulation, other things. And also he has made many feedback mechanism that leads to warmer Bay of Bengal, and also the low pressure system in the Bay of Bengal. And finally, he made also reference to the various climate modes, and including the importance of the equino and our understanding. And finally, Dr. Krishnan has summarized the uncertainty and reducing the various climate model processes, especially the migration and dynamics of ITC set and convective process in the various coupled models and also the what is called various climate modes, ENSO, IOD, and Pacific decadal oscillation, how it plays, and how the weakening of the water circulation is happening in the CMIP and other things, and the present status of the climate model, how it is, and where we need to improve the climate models. All these things he has nicely highlighted. So these are the major summary which I have noted down. Of course, there are many questions will be there. Maybe in the, I am not sure how the climate model, how the IC dynamics are represented in climate models. And also that is a major laguna. It is still, it is not set it all right when you talk about the climate modes, and also the monsoon things also, we need to have more and more observation and other things. So these are the some of the highlights of the today's event. Maybe I leave it to our panelists.
Sir, few questions asked from the YouTube. I put in the chat box, sir.
Yes, I'll ask that one. Maybe before that, I will leave it to our panelists, all the speakers. Maybe if you are, maybe according to you, maybe one of the important pressing questions which we need to address. What do you feel that if you are able to tell, so that people can try to address or look into this one? Maybe each one of the speaker, if you are able to say that, yes, we need in future what we need to do, that if you highlight, it will be nice. Maybe in few sentences.
Sir, there are some questions answering that also we'll have to answer, which there are many questions in like that.
Yes, I will. Okay, Mokanti Saab, you can start that.
Is there any question there?
Not the questions, but suppose if you want to address one of the important, maybe one important questions which you want to address in the future, maybe few years, especially in the cyclone. So what do you feel that, what are the important questions or important things to do in terms of improving cyclone forecasting?
Yeah, obviously, as you know that we have improved the prediction of the track and landfall, but intensity still, we have to improve the intensity. And as I have shown you, intensity prediction needs more coupling of atmosphere, ocean, and land. Any the gradient in these processes. These gradients, like you see that when a cyclone is moving, there's so much evaporation and temperature falls rapidly in the core of this cyclone. But if you are putting SHT as a fix, you cannot get that gradient. Therefore, all studies in atmospheric science leads a surface gradient, and that will be well represented if you have a coupled land, ocean, atmosphere model, so that they can interact. So therefore, the main question is now to have these three processes should be coupled together. But for coupling, major thing is that data. So data assimilation of the coupled system is one of the most important aspects to run a coupled land ocean atmosphere model. So assimilation of the land surface data, assimilation of the ocean data, and of course atmosphere data is assimilation there, but there is always scope to improve assimilation with more and more observations. Therefore, the tropical cyclone future is that it to have a coupled land ocean atmosphere modeling system with interactive assimilation.
Okay, okay. Thank you, sir. So just one question to Dr. Nayak sir. So you can tell us, I think you have listed various activities of blue economy. I think it is a lot of issues and opportunities you have highlighted. Maybe which one we have to take it immediately and seriously as the oceanographic and atmospheric community, especially if you highlight maybe in few sentences, that will be great. Sir, your mic is muted, sir.
One thing which is most critical and immediately we need to address is how do we integrate our scientific data, which is a huge data already being collected and continue to collect. Now, when we want to use this information for the economy, which includes all the surveys and the observations and everything, satellite, I mean, I'm not differentiating anything. How do we integrate this with the social and economic data? Because this, all data sets are in quite disparate forms. You know, it is not similar. So that is one area I think we need to start understanding, because otherwise what will happen, we may do something, but whether it is linked to economy or social economy, it won't be known. At least Ministry of Earth Science does a lot of such surveys, which we, National Council of Applied Economic Research and all. Yeah. But that is only the benefit of the service. What I'm saying that from the data itself, we have to take it them that how it is going to. So that is one thing which is very important. And second thing which I think very important is as far as blue economy is concerned, the current structure of governance will not work because there are so many different players. Though Ministry of Earth Science has to coordinate this activity, but there are shipping, tourism, and number of other ministries who get involved. So the institutional mechanism, they all work in unison. That is another area which is, I think, is very important as far as blue economy is concerned. I'm not much worried about the science part because there are few issues which we need to, like exploration or a survey, which there is no problem as such. It is only putting additional funds and additional people to do the work. We know what to do, how to do. But these are the areas where we don't know exactly how to approach this. There is no definite framework or mechanism available. So I think we need to put our efforts on that. And that generally, you know, we scientists don't want to get into those aspects. But I think it is necessary now to do that.
Yes. Thank you, sir. I have one or two questions are there. Maybe Dr. Shana, it is addressed to. I think you have already mentioned, but you can clarify. Do you think that if we pursue the program of interlinking the rivers and more damming of major rivers taking place, the flow will reduce to the Bay of Bengal and consequently affect the monsoon? This is from Dr. Baba.
Yeah, I don't have a simple answer for this. I can only give an example. See, when I was in NIO, that's the time there was a big controversy about Karnataka is going to construct a dam over the Madai River. Mahade River is the one which flows as Mandavi in Goa. So a lot of activists in Goa were opposing that tooth and nail, that if the Karnataka constructs a dam, entire Goa will get destroyed, no water will flow, blah, 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 all those things. So that time I just did a rough calculation, how much rainfall is received from the within Goa itself, and including this catchment area of Mahade, which is mostly spread over Karnataka region, and how much of that water is used in Goa. So I was surprised to see that not even 1% of the water is required is used in Goa, and other 99% of the water is just flowing out. So unless you do a calculation of this sort, how much water will stop from flowing to the Bay of Bengal if you do go for the interlink project, we cannot answer that exactly. I think these projects have larger benefits, and we have to look at more critically from data and the scientific knowledge rather than but it is a fashion these days that just to create confusion in the society and stop any developmental activities. So I don't have a clear answer unless we do a calculation.
Yeah. Okay.
Thank you.
Okay. Okay. Thank you, Dr. Senai. And Kristen, so what is your one single most objective or agenda, maybe the next few years, for improving the climate models?
Yeah, sorry. Yeah. Okay. So two things. One is we want to improve the connection between the wind and the convection or the monsoon. Improve the convection. The other one, how to improve the Walker circulation and the SST gradient, or even the ocean, the Indian Ocean. So that is, these two areas are two focus points. So
thank you. Okay, thank you very much. I think though we have taken half an hour late, but it is more informative, and it is really we have coupled one. We have talked about both ocean and atmospheric coupling related issues, and I sincerely thank you all, especially the speakers. I think you have taken a lot of time for us, and you have given a lot of time and a lot of information and knowledge, and we sincerely thank you for all your what is called talk and knowledge. And both IMS and OSI, we thank you all speakers as well as the participants and all the other colleagues and friends. Thank you very much. Thank you very much.
Thank you, Dr. Ravi. Thank you, Dr. Mahapatra. Thank you very much. Thank you all.
Dr. Abhitandan, one suggestion to be a member of either IMS or Ocean Society, you should have a form and online transfer process instead of check or this thing. Because with COVID, it's not possible. All these things. So I think both the society to have more members from both sides, you should start an online form and also
definitely.
Online money transfer.
Yes, sir. Thank you. Thank you all.
Thank you, sir. Thank you all.
Thank you, Chair Ravichandran sir, Mahapatra sir, chairing the very important session. We got a lot of discussion on ocean and science, and all the distinguished speakers for nice presentation. And it will be available in YouTube, and also it will remain available so people will watch. Many requests were there that if you can share the PPT, some people have shown some interest, so that also we can upload it PPT there. And finally, I thankful to all the IMS President Mahapatra sir, OSI President Ravichandran sir, our Secretary from OSI Jena sir, our colleagues from NC, Dr. Anand Das, and all my friends here in IIT for nicely supporting this event. And thank you very much. And we'll meet again sometime. Frequent coupling should be there so that some event will. Miss Ocean and Miss Atmosphere will work together. Thank you, everyone.
Thank you, Dr. Patnaik. Thank you, everyone.
Thank you all. Thank you.